All right. Good morning, Berlin. How are you? It's like still a little sleepy. Oh, what a night! Or it's like, I mean, that's probably a good sign because that means that you have like made the most out of the time. That's actually a good thing. I hope you have enjoyed the last day, yesterday, in terms of the talks, presentations, but also conversations, interacting with the others. So also while I'm talking, please come in, please motivate the others outside, because we want to get this started. Take your seat, relax, and I think while I'm also talking, maybe you can do like a little check-in. So who of you is like a first-time attendee here? That's a little, about half, all right. Who has like more than three CTI conferences in the books? All right, that's also good. Who will be there next year? Come on. All right, no. So before we start, also I just want to highlight two organizational aspects. First, specifically, thank you again to our sponsors. You can see them on the list, so make sure, to go to their booths, check them out, interact with them, and also a very small heads up, this is the second point. We will have a feedback survey, so about the conference, about the talks, about the workshops, about the speakers, and make sure also keep that in mind, eventually making some notes that would be really helpful for us to progress, to make this a better conference also next year. I think that's it. We are all waiting for the next session. The next session, or the next three talks in the session will particularly try to, I think, cover the application of CTI in various or different fields, domains, also highlighting aspects of that. The first talk will be TLP Green, so please follow the rules. And our first speaker will be Reese from Ericsson, and he will elaborate on CTI in a PSERT context. So please join me in welcoming Reese. Yeah, next up, our last talk for the session, we have all the way from Australia, Paul, who will integrate software supply chain intelligence into a regular CTI program, I guess. So please also join in welcoming me. Paul, the stage is yours.
Thank you so much for that. At the beginning of my talks, I like to take a selfie of me in the audience. And I know some of you might not want to be in that, so I'm going to take a selfie. And if you want to, you can put your hand in front of your face so I can't see you. Make sense? We all cool with that? All right, let's do this. All right, here we go. Booyah. Thank you so much for that. I appreciate it. By the way, unfortunately, DEF CON has been canceled. I'm sorry. We got a couple of laughs there. Good day, guys. My talk is, let's see. How do I? Oh, okay. Well, there you go. I should hit that. My name is Paul McCarty. I am an American living in Australia. I've worked for large organizations and small organizations, lots of startups as well. I've been in IT for over 30 years. I am known for being a DevSecOps guy. I'm also known for my NPM malware and my offensive security work in the software supply chain. I've recently taken a role with Safety, which is a Canadian startup in the software supply chain space, as their head of research. I'm really excited about that. Safety is building a software supply chain platform for businesses. Why did I put this presentation together? This is kind of a crazy topic, software supply chain threat intel. I wanted to put this presentation together because I want InfoSec and CTI practitioners to understand there's legitimate good data that you can get out of software supply chain attack components and bring into your CTI programs. Now, I've only got half an hour. I'm going to try to leave some room at the end so I can take some questions. But first, let's talk about the different types of supply chain or software risks. The first type of risk is the accidental vulnerabilities. These are the kind of common vulnerabilities that software engineers accidentally create in source code. So we're talking about not sanitizing input, not encoding output. Think about the OWASP top 10. These are the kind of things I'm talking about, right? Now, there's a bunch of security tools that address this market, ASPM and other tools. You see that in that box down there on the left bottom. And those tools produce findings. Now, findings that these tools produce are not something that most InfoSec teams can natively consume. These findings are things like, hey, this library has this particular vulnerability, but only if you actually call that function or use this particular class or something along those lines, right? That's not the kind of thing that CTI practitioners can easily consume. Now, counter that against the other type of software risk, which is the intentionally malicious. The intentionally malicious software-based attacks are created by bad guys, by criminals. They obfuscate their payloads. They use native JavaScript payloads. Those payloads still have C2. They still have exfil endpoints. And unfortunately, they have install scripts built into them, too, as well. Now, if you know what to look for inside of these intentionally malicious threats, you can find things like IP addresses and domain names and usernames and file hashes. And that's why it was so important for me to put this talk together for all of you. So there's a lot of companies in the ASPM kind of application security space. The whole industry is kind of focused on that first group of accidental vulnerabilities, but nobody's really kind of concentrating on that second group of intentionally malicious. I spent 7 years at my startup, SecureStack, trying to address this problem via ASPM, selling application security tooling, trying to sell that to security teams, and it just didn't work very well. And eventually, I shut down SecureStack. Now, part of the issue is that people think that the tools they've procured have actually protected them from these threats that I'm talking about, these intentionally malicious threats. So for example, AppSec teams and engineering teams believe that the software composition analysis tools, things like Sneak and Sonatype, help them with these malicious packages. Well, guess what? They don't. Similarly, when you have conversations with CISOs or InfoSec teams, they hear malware, they hear like open source malware, and they think, oh, my EDR, that's got me covered. Well, guess what? That doesn't work either. So we have this gap in understanding. AppSec teams, CISOs, they think their tools are covering themselves, and they really aren't. And that's why I wanted to talk about this today. So this is a project that I created a couple years ago called the Visualizing Software Supply Chain. And the idea here was to help people understand the breadth and scope of the problem. So there's 10 stages in my visualization, starting at the far left, which is the software engineers, working on creating applications. Then the local environments they're using, their Git, their Mercurial, their IDE, Cursor, Windsurf, things like that. Next is the actual source code they're creating. Then the integration phase where you take those disparate pieces of source code and branches, bring it together into a unified code base. Next is deployment, where you actually take that unified code base and you do something with it. Then, when you've done something with it, it's now in runtime, it's running on servers, Lambda, what have you. Maybe your application requires a GPU or some other kind of hardware component. So, interestingly enough, sometimes a hardware component can be part of the software supply chain. You take that GPU away, you can't build or run your application. That probably means it's part of the software supply chain. Similarly with DNS, if your users are used to calling app.example.org, and that goes away, well, guess what? The application doesn't work. So that should be thought of as part of the software supply chain as well. Finally, the last two stages, services. This is a catch-all for all those kind of things that are in your application that are not in your source code, API gateway, app sync, things like that, right? Payment gateways, what have you. And finally, the cloud. If your application is deployed in the cloud, or if your application calls native cloud components, that should be considered part of the software supply chain as well. But today, we've only got half an hour. And so we're going to talk specifically about malicious packages or open source malware. Bad guys deploy these malicious packages through a number of means. Dependency confusion, account takeover, where they're actually targeting the maintainer or the author of packages. Typo squatting, which is actually a very, very effective technique. We see right now that AI is unfortunately hallucinating the names of packages. Bad guys go and then create those malicious package names, and suddenly this is a new attack vector. Browser extensions is another one where bad guys have learned that can get me into a developer's browser session, steal session tokens, etc. And finally, AI tooling. A lot of the malicious attacks that we're seeing are targeting Cursor, Windsurf, and these kind of components running on a developer's laptop. Why I want to talk about these package-based attacks in today's short talk is because you can use malicious packages to affect so many of the software supply chain stages. You can use it to target a developer or their IDE or their AI tooling. You can use it to target runtime or the CI/CD pipelines. So malicious packages themselves are a very flexible tool for bad guys. We're going to talk specifically today about NPM. Why? Because NPM is the epicenter of the malicious package ecosystem. 98.5% of malicious packages exist in NPM according to Sonatype. I'm going to say that again, 98.5. PyPy is number 2 with less than 1%. Take that into consideration. It's a shit show. Amplify that with the fact that JavaScript, kind of by definition, is very broad, has a large attack surface. This is a study from GitHub that shows that the average JavaScript project in GitHub has 10 direct dependencies and 683 indirect or transitive dependencies. Number 2 is PHP with 9 direct and 70 indirect or transitive. That is an order of 10, right? So what I'm trying to show you here is that the JavaScript ecosystem, by definition, has a much, much broader kind of attack surface, and that is why bad guys like to deploy there. A little bit about why I call NPM the most malicious registry in the world. JavaScript, as I said, has a history of no batteries included. What that means is that, by definition, when you install a package, a JavaScript package, it's going to install a bunch of other packages. And then those packages are going to install a bunch of other packages. And those packages are going to install a bunch of packages. That's not the case with other languages. JavaScript is kind of unique in that way. Next, NPM packages actually have pre- and post-install scripts. This is remote code execution by design. When you do an NPM install, when you do that, the pre-install script runs right before that, and the post-install script runs right after that. This is the perfect opportunity for bad guys to deploy their packages, their malicious payloads. And the barrier of entry is really low. Like, anybody here can go and create an NPM account and start publishing packages right away, public packages right away, targeting typo squatting or dependency confusion. And even worse, this is crazy, even worse, anyone can claim a namespace. So if, for example, let's say npmjs.com/Microsoft is available, which it isn't, but let's just say it was, you can grab that namespace, and then you can deploy inside that namespace. You don't have to prove that you're from Microsoft. You don't have to prove that you own that domain. If that namespace is available, you can grab it. And bad guys take advantage of this by grabbing new name spaces for like projects that are on GitHub before they've gone and built something in NPM, and then they've gotten the name already. Oh yeah, actually, the JavaScript also runs in the front end or the back end, so that gives bad guys a lot of flexibility about how to, target their who it is that they're actually specifically trying to target. This data here is actually from a SafeDep survey that came out a couple of days ago, and just kind of shows what specific behaviors malicious packages do. So 78% of them abuse those pre- and post-install hooks, those scripts. 65% of them exfiltrate system information. This is super common. 52% of them use code obfuscation. Now, here's something about obfuscation. I've heard InfoSec peeps say in the past that if JavaScript is obfuscated, that equals malicious intent, and that is not the case. So you can't see an obfuscated JavaScript component and think, oh, that's malicious. You have to dig in, you have to de-obfuscate it, figure out what it's doing. And the reason why is a lot of legitimate engineers use obfuscation to hide business logic and other kind of stuff that they don't want you to see. JavaScript runs in your browser, so you can see the code, right? It's that simple. They have hard-coded C2 infrastructure and a bunch of other things. Down there at the bottom, executing arbitrary shell commands, 12%. My experience is that number is much higher than that. I would say that is more like 50% or higher. All right, so here's the good stuff. Let's actually look at some specific malware examples, and here's why. Remember, the point of this conversation is for me to show you that you can actually get legitimate threat intel out of malicious packages. I want to show you how easy that is. In this case, we're looking at a really simple malicious package called Hero Stereo. This package only had one file, the package.json, which is the manifest for that package. You can see clearly there on line 7, the post-install script, so that's that script that runs right after you do an npm install, it runs that, is using ncat and connecting to that IP in that port and then spawning a bash shell, right? Do you see some legitimate threat components there, right? This allows us to add that IP address and that package. If you see that one of your developers is using that package, if you see egress to that IP, well, you can kind of assume that there's a potential compromise there, right? It's that simple. This author also created 6 other packages, all of which had very, very similar payloads. So that means that you can then search through all of your package manifests and SBOMs and what have you, looking for those packages. So here's another one, another really super, super simple. I mean, by the way, most malicious packages are not this simple. I'm using these because they're really easy examples. But this one, again, is using a post-install script, and it's obviously curling that Ostify, that's a burp collaborator endpoint, right? And then it's exfiltrating the host name, username, and the public IP address. These are super common. There are literally dozens, maybe even hundreds of these deployed every day to NPM, typically by security researchers or bug bounty researchers. Now, this one is pretty, somewhat harmless, right? Host name, username, and public IP. They're trying to prove intent. But I've seen a lot of these security researchers exfil etc password, etc shadow, and other things, which crosses a ethical line. So again, we've got some components here, things that we can add to our threat intel work. We can look for any egress to any of the Burp collaborator domains, ostify.com, os.pro, os.me, so on and so forth. You can also look for the existence of that package being installed, right? If you see either one of those, well, guess what? You probably have a compromise. All right, now here's a more nuanced, this is where we get into the sexier stuff. Web3 parser. This is a package that I identified in January of this year. Web3 parser is a malicious package, JavaScript package. It's basically copying a well-known Web3 event notification package called Web.js. Basically what it does, well actually, first and foremost, you can see that it's not using a pre or a post install script. So then what you do is you look for the main line, and that's the entry point. So basically, in this case, this package, to deploy its payload, has to actually be imported and then call that function, or call one of the functions that is inside of that package. So let's take a look at the index.js file. Ooh, that doesn't look right. That is a obfuscated and minified JavaScript code. And, there we go. I've cleaned this up for you. I've de-obfuscated it for you. And you can see there on line 5 that it's declaring a variable, an array, that includes 5 base 64 strings. And down there in the red box, I've actually decoded that for you. It's pretty straightforward, exfil endpoint, api.tradenode.com. Now here's the thing. That package had been around since 2022. People had been using that package for 3 years by the time that I identified that it was malicious. And if you looked at those different versions, what you saw was that over time, it evolved, and the payloads evolved, right, and what it was doing. So this is a later version of it. Instead of having those 5 base 64 strings, it's got one big one, and that one big one points at a MongoDB instance in the MongoDB cloud. So in this case, we've got a bunch of things that we can, a bunch of threat intel kind of components and indicators of compromise that we can add to our CTI data set. The domain names, the package name, and the IP address that that A record was pointing at. Now here's one that I just found last week. I've got a really cool write-up on this on the safety blog. But basically, this is a package pretending to be part of the Express JavaScript web server. And you can see there, weekly downloads, 4.5 million downloads. That's crazy. All right, so let's go ahead and take a look at it. Sure enough, it's using a post-install script. So let's, oh, and then in this case, the post-install script is not actually running commands, you know, like we saw earlier, the curl and the ncat. In this case, what it's doing is it's running node and then calling the index.js file. So let's go and take a look at the index.js file. And again, we see a heavily obfuscated package. If I clean that up for you, you can see there on line 23, it's calling PowerShell, and it's pulling a first stage loader from ASDF11.xyz, right? And as I'm not going to bore you with the whole, you know, attack chain here, but as I drilled into this and researched this, there was a second stage which was calling out to a .su domain, and it was pulling a payload that included 3 binaries. And so in this case, we've got lots of IOCs that we can add. First, we've got those 2 domains, the .su domain and the .xyz domain. We've got the IP addresses that both of those A records point at. We've got the original package, but this bad guy also created 9 other packages, all of which have the exact same payload. And those 3 file hashes there at the bottom are hashes. If you actually take the base 64 strings, decode them to the binaries, those are the file hashes for those 3 components, which were a crypto miner, Luma stealer, and actually another info stealer as well. All right, so how can we take what we've learned here today and start to build our own kind of CTI understanding and capability? Well, the first thing we can do is we can kind of go out and find the resources that we've got. The first place I like to talk about is osv.dev. osv.dev is a global vulnerability database of both accidental vulnerabilities and intentionally malicious vulnerabilities, and we're going to be talking about that second one here. It's run by OpenSSF in conjunction with Google. Now, the problem is that if we take a look at a specific advisory for a malicious package, that JSON has no threat indicator data in it whatsoever. Doesn't even have the author. Doesn't have the IPs, doesn't have the domains, doesn't have any of the other packages that author created. It basically just says, this package, these versions are malicious. So that's good. That means you can then take a key value pair, which is a package and a version. You can go to osv.dev and you can identify whether it's malicious or not, but you can't get that threat intel. Now, the other website I want to point out is the GitHub Security Advisory, or GHSA. Same thing as osv.dev. This one's owned by GitHub, which is owned by Microsoft. And you can go and find malware, as well as those accidental vulnerabilities, in the database. But the same thing, if you drill into the actual advisories, you're not going to get any of that threat intel. So you can go and check and see whether or not that package is malicious, but you can't get any of that juicy, good CTI stuff, right? So what I suggest you do is that you follow this quick playbook. Basically what you do is you create a software inventory. And the best way to do that is to take advantage of SBOMs. And I don't know how many of you have heard about the whole SBOM thing, but SBOMs are actually a very, very valuable thing in the sense that they include all of the packages and components that a particular application needs. But even if you don't have SBOMs, you have those package manifests. And what you can do is you can use some really simple tools to parse those files to get the package name and the version number. You can then take that key value pair and go over to OSV or GHSA and identify whether or not it's malicious, right? If you find a hit, what you can do is you can download the tarball or the zip file, you can unzip it, you can inspect the source code, and find those juicy threat indicators that I was showing you. Excuse me. All right, so this is one of those tools I was talking about. This is the SIFT SBOM tool. Basically, you run this on a package. So on the left side, you see this is a Python package, and that's requirements.txt. That's the package manifest for a Python file. SIFT is actually parsing that, giving us the package names in the left in the first column. In the second column is the version. Same thing on the right. This is us using SIFT on a JavaScript package. Again, the first column is the package name. The second column is the version. You can use SIFT to pull those key value pairs out for you automatically. So lastly here, I want to talk really quickly about a CTI portal that I built specific around software supply chain threat intel. You can think about the data that I'm going to talk about here as a graph. In the upper left-hand corner, you've got the threat actors. Those threat actors are creating threat campaigns, which are on the right side, upper right side there. And those threat campaigns might use one or more NPM packages. And finally, those NPM packages call out to a set of indicators, C2, files, exfil, so on and so forth. But those campaigns might use those same ones. In fact, I was researching this morning a new attack, 57 different packages, all different NPM users, but it's all using the same kind of infrastructure, right? So let's take a look what that looks like in practice here. There's 3 tables that I've created in my threat portal. The first is the threat indicators. These are the NPM packages. These are the file hashes, the kind of classic things that we've been talking about here. And each one of those is then connected relationally to a threat campaign and a threat actor. If we go to the next table, we're looking at threat actors. Far left column is the name of the threat actor. Sometimes that's an individual, sometimes that's a group. I've gotten good enough to actually drill down sometimes into the actual humans that are behind these threat actors. And I often can find, using OSINT, their LinkedIn, their GitHub, very common, Twitter. Criminals love Twitter, enough said. So that's our threat actors table. And finally, there's the other side of the threat actors table. And finally, there's our threat campaigns table. Threat campaigns is that overarching abstraction that sits above. A campaign has a specific intent. For example, it wants to steal wallet keys on developers' laptops or something along those lines. That campaign then calls out to one or more NPM packages, and then those threat indicators, the C2, exfil, so on and so forth. All right, So wrapping this bad boy up. Here's some tools that I suggest you take a look at. I'm a big advocate for using source code firewalls. This is basically something you install on your developers' machines. Basically, what those tools then do is they identify the packages that they're using, the packages they're pulling. Some of the tools will actually only allow developers to pull from certain registries, which is good. So if you've got a known vetted registry, your own, you can force them to only use that registry and not go around that. For example, there's a lot of Chinese NPM mirrors that have varying levels of maliciousness inside of them. One of the open source tools is Datadog's supply chain firewall. But then safety that I work for is also building one. Sonatype has one as well. And that brings me to the end of my talk. I've got 2 blogs there. I've got my personal blog at the top. If you want to read about some of my threat hunts and some of my work, you can read there. More recently, I've started writing blog posts on the getsafety.com website. If you want to reach out to me, there's my email at the top and my GitHub profile. Thank you so much for having me here today. I hope that you guys have learned something. I really, really appreciate it. Thank you so much.
Great stuff. Questions? We do have time, so please feel free. Oh, over there.
Hi. Hi, thank you so much for this very interesting presentation and all of the here.
Hey, I see you.
Hello. I just want to say thank you, and I want to ask you, like, how are you putting the data into the Airtable? Are you automating, like, the campaigns? Like, how are you tagging? How are you pulling those identifiers for each of the campaigns and the threat actors? Are you doing it manually, or do you have an automation in place? Thank you.
Anyways, good question. So yeah, today, because I only had half an hour, I had to just cut out lots of stuff. But you're right, I have written automation. It's totally automated. Basically what I do is when I identify that a package is malicious, I pull that tarball, I expand it, my automation runs through it, finds the threat indicators, automatically uploads those to Airtable, creates the threat campaigns, the threat actor, and the threat indicators. So yeah, it's all totally automated. Good question.
Another one?
My fellow Australian Chris. G'day, mate.
Yeah, I was wondering, as well as the portal you've built, are you aware of any sharing formats that people are using for the attribution campaigns for this type of stuff?
Yes. I think it's super early days, Chris. And I think one of the reasons I wanted to bring this here is to kind of expose people. I think those kind of sharing formats, that's something that the existing CTI practitioners probably can bring some maturity to the space. Because the reality is, like, none of the tools right now, some of them export in serif, and some of them have some sticks connectors and stuff like that. But it's super, super early days. So the answer is not really. But we need that maturity from the CTI community to come and help build that.
Yeah, might be a good one to have a chat about later.
Yeah, for sure. I would love that. Oh, we got one right here.
Oh. Sorry.
Hello, another fellow Aussie. Thanks,
nice.
Paul. I love how you're thinking of it like a graph. Yeah, that's
100%.
that's really awesome stuff. And that repo or that portal that you've created, essentially quite a graph database, right? And I don't know if you had any thoughts of visualizing that or adding any sort of extras on top of that. Yeah.
Great question. So I'm working with another Australian, Peter Freeberg, who's a friend of both Chris and I's. And Peter spent a lot of time kind of like doing that visualization and that graph kind of representation. I've learned a lot from him. I export right now out of my database into Neo4j, but I want to get better at that because that graph is super, super powerful. And that's because as I learn and as more data goes in and you start connecting these threat actors through these indicators, you start seeing how big, these groups are. So absolutely, that graph nature is 100% where I want to go with it. Cool. What was your name? Adam. Oh, you're Adam. He's the other one. Yeah. G'day, mate.
All right. Maybe one last from my side. Having seen all the package JSON files and also from the NPM repository, have you tried to scrape them all and analyze them at scale?
Oh, 100%. Yeah. So basically, my automation pulls every single new package every single new package out of NPM and PyPy. Those are the only two I'm doing right now, which is a lot of work. So I've got multiple EC2 instances in AWS doing this 24 hours a day. Pulls them, blows them apart, runs like 44 different rules against it, pulls out those threat indicators, then it sends it over to Airtable. So 100%, yeah. You have to look at every single package.
Perfect.
Cool.
All right, Paul,
Thanks
thanks
so
again.
much. Cheers.
Now we are at the end of the first session, meaning that we have a networking break for 30 minutes. So see you back at 11 o'clock in time. Thanks.
coffee break. We continue with our talks. The next speaker doesn't need to be introduced. I think I've seen you in every first CTI here in Berlin. So, Alexander, the stage is yours.
Thank you. Awesome. Thank you very much. So maybe the presentation I will do today would be a bit disturbing because I think it's a presentation that we decided to do based on some internal discussion that we had at the office regarding what we actually do on a day-to-day basis with pivoting informations, which we actually do like for the past, I would say, 20 years for doing trade intel. But we think that we're missing some parts, and I wanted to show you some practical example recently that we discover while pivoting and what is all about on our day-to-day activity. So first of all, it's just like I would say the theoretical part. So you might ask, what is all about pivoting? What are we talking about? And so on. So today, my point of view will be about what we call defender pivoting. So that means as a blue team, as a SOC operator, as an analyst, as someone doing day-to-day activities in trade intelligence, is actually pivoting to find out additional information, especially to pivot from known artifacts, so meaning indicators, could be indicator of compromise, but it could be attributes, information that you collected, to actually uncover additional information. In the previous presentation, we saw that, for example, collecting packages, extracting the information there from email addresses, indicators, and so on can lead to new details about infrastructures, what the attacker is actually doing, and so on. So it makes a lot of sense. We are actually doing on a day-to-day basis to not confuse with what the adversary is doing. While we say pivoting, where it's basically sometimes causing confusions in naming, where it's more like lateral movement. So when an attacker is basically compromising an infrastructures, when we say he's pivoting, then it's more the act of moving across the infrastructures, but it's not what I'm talking about today. Nevertheless, I will talk about threat actors and what they do. So that's really the idea. So pivoting, I think it's art. It might be a science too, but maybe we need to dig a bit more into that. So if you look into pivoting, and maybe some of you know this kind of old game, you have what we call the 6 degrees of Kevin Bacon. Maybe you play that game. So you were crawling the internet and finding an actor, an actress, and you were finding a path to the closest path to Kevin Bacon because he was very close to the Hollywood movies and so on. So the concept of 6 degree separations, it's kind of mathematics. There are some mathematical analysis of social networks. I think the 6 degrees is like applicable to a lot of networks. So meaning that 2 individuals or 2 data points could basically connect it to a chain of at least 6 or even sometimes fewer points. So recently, I think for Facebook, it was like 3.5 or 3.7. So depending on the size of the networks. And I will come back to that because if you collect information from threat intelligence, you basically build a network. And these networks might have some similar properties, and those properties can be actually reused. The only difference I would say for this is not only people, but it's actually data points, so it could be infrastructures and so on. So if you dig more into that networks and how they are linked, you might reveal some interesting aspect. And even for us, on a day-to-day basis, we discover that they are linked that we were like not looking at and that may be of interest. So if you look at the classical pivoting things, you have like 3 objectives while doing pivoting, or we say 3 benefits. One is actually understanding what's going on. So I would say the current view. So you check live infrastructures, you check, for example, the different communication scheme, what is active and so on. You look at the operational pattern from the attackers, make a lot of sense. Then there's, I would say, something that is sometimes interesting is historical. So if you are digging into, for example, which data set, passive SSL recount, even SSH, key fingerprints and so on, you have this historical data set. And then sometimes, if you see a regular patterns, you can predict what the attacker will do. Because it's a recurring patterns, he will use the same techniques, or he will, for example, use a specific subdomain in specific domain that you monitor. That's really a recurring and even predictive one. So that's everything is fine. It's theoretical approach, and everyone is happy. But if you look carefully, I think we maybe are wrong. And I think we did the mistake. And there are a lot of presentations. I remember some very good presentations from First CTI and other teams doing things that it's coming from art, and you make it making practicals, it's actionables, and so on. You basically create models out of that, and so on. But when you start to create models, you prioritize, and you have first-class citizen for indicators, which basically is kind of a legacy practice, but you sometimes discount some point that might be of interest. For example, in a lot of slide deck, and I haven't seen it for the past 2 days, but usually we see the pyramid of pain. Now we can ask the questions. Maybe this one is a bit challenging. Or is it really difficult for an adversary to alter high-value indicators? The question is, do we really care? I mean, maybe some threat actors doesn't care about their indicators. They don't even look in the pyramid of pains. This model is maybe too artificial too. So maybe the threat actors don't realize that they are actually leaving traces. So maybe we should go a bit further. And I think for us, one of the pivotal points that we had at the office discussing about this kind of pivoting was the case from Anna Senpei, and maybe some of you know it. It's when Mirai came, and we were analyzing the malware and so on, and when digging into social networks, we find out who was the author of Mirai. And it was, at the end, it was a user account on a Minecraft server. So maybe sometimes we have this kind of rigid process of doing threat intelligence, pivoting, and so on, but maybe we need to improve that and be a bit more creative on that aspect. So we decided to go a bit dirty, I would say, and we were reevaluating our indicator collections in one of our projects that we do for monitoring dark web and so on. So we collect social networks, story-done services, we collect even we are crawling some specific web interface from threat actors that they are exposing. But we change the model of correlations. So the correlation is like very strict. We have if we can create a new data type, we decide to do it, and we try. And this is quite interesting because it's giving us a very interesting aspect. We were focusing more on the outliers. So things that are not usual, things that are out of the line, I would say. And some data points were completely overlooked. And so today, what I want to show to you is those practical examples of things that are completely overlooked, but that might be of interest for the threat intelligence team. And you'll see you have very, very simple things that give very, very good results. So first of all, and it's another issue that we have seen a lot of documentations mentioning that the format of some indicators are bad because they do collisions. If you are part of, I would say, threat intelligence teams, you have to deal with hashes of malware, binaries, and so on, and a lot of people will tell you, don't use MD5. It can collide. But is it an issue, technically? Is it an issue as a threat intelligence team? So we have exactly the same discussion recently about Murmur hash tree. Maybe some of you know that. It's usually the algorithm used for favicon calculations. So for example, if you use Shodan and you search for a favicon, you actually use a Murmur hash value, which is usually a signed integer with negative value or positive values. But this one is flawed. It's not a cryptographic hash. It's a very fast lookup hash, but it's not a cryptographic hash. There's a lot of collision and so on. But nevertheless, it has a lot of weaknesses, but it remains super effective. I mean, we are still discovering, de-anonymizing Tor-hidden services by using favicons. Another thing that is interesting too, if you know that you have collisions, maybe it's interesting to monitor the fact that people are trying to do collisions, because it's giving more insight. So instead of actually discarding the hash itself or the format, because it might generate collisions, take into account in your software that you might have collisions, and those collisions might be interesting for a threat intelligence analyst. So it's quite interesting, I think, mindset that you have to change, and we recently changed it for some of our tools, so that we have to question what kind of algorithm which can be abused by the threat actors and the attacker. So now going into practical example. This one is, I think, a pretty nice one. So this known hash there, it's for a well-known forum in Russia, which is used for advertising markets and so on. And what you can immediately spot with what we were doing, even if the murmur hash can collide, this one is still giving a very good set of results from public services. By the way, it's FOFA. Maybe some of you know the platform. It's a Chinese platform, very good. Chinese has very good product and open source tool. So if you have to move away from US product, maybe look at Chinese product. By the way, if you look into the correlation engine that we have, we see that there we have a favicon correlations. And this one is interesting because you basically have the favicon here with the correlations, but you see you have some other correlations that are not completely linked together, like Google tracking, I will come back to that. We have a reference to a Telegram channels. We have one only mentioning a beacon address and so on. But you see that you start to have an interesting path there of correlation that you can dig into it. For example, another example is a title page. Title page is an interesting indicator. If you have a set of pages within a specific context, like Tor, maybe the title page correlation make a lot of sense. Obviously, if you have title correlations on the Google scale, it doesn't really work. But if you have a set of websites that you crawled and collected, maybe those are interesting. So, for example, recently we discovered again some child porn websites that were basically hosted in Clear Web 2, and just by pivoting from the favicon, we could basically find where they are hosted. So that's quite interesting for law enforcement. Another one that is interesting. So one of my colleagues was like, yeah, but you know, we start to have a lot of those messages from social networks. And the thing that was quite interesting, a lot of the social networks nowadays are meme, images, screenshots, and they don't even talk. So the problem is you have a lot of semantic in images that you need to analyze. So we decided to dig into that, so take the images and do extraction. So for us, the easiest first extraction was QR code. Oops, sorry. The extraction of QR code was interesting there. Oops. So this one is showing actually the number of QR code that we extract on a daily basis. So it's quite a lot. And this is basically QR code on Tor hidden services and Telegram channels and Discord channels. So there are some. This one is interesting. So this one is on a QR code. You basically, when you extract a QR code, you basically have a value. This one is a prefix value. And the prefix value for this one, you see there, but it's a bit small, is a tox, double point, then a hash. So those ones are used for ransomware and ransom group negotiations. They give to the victim a QR code to run their tox client. They can connect and they can start to negotiate. But the thing is, the threat actors have to share that. So they don't actually share the reference to the tox. What do they share is basically a QR code. And that's an interesting one because you can pivot from that QR code and see where this is mentioned in other channels and so on. So even if the image is completely broken and so on, as long as the QR code is parsable, you basically have correlations. That's a quick win. Another one that is interesting, when we show that to law enforcement asks us something very strange. And they say, oh, you know what? I'm very interested not in QR code, but in barcode. And I was like, okay, barcode, it's easy to extract. So in barcode, it's a mess of code in different formats and so on, but there are some very good libraries nowadays, even for using image detections and so on. So if you are familiar with that, you have code 128, code 39, which is the most common one. But those one are valid point. And for example, police were very interested into that because a lot of groups that are doing cash out are actually doing pictures of delivery documents from carriers and so on, which contain barcode, which is interesting. But when we started to have that, we said, okay, we should run that on leaks. And the thing that is super interesting, a lot of leaked documents contain barcodes. So even if the leaked document is difficult to parse and so on, you have a correlation point, which is like a barcode. If you have an identity card in Europe, for example, on the back of the card, you have a barcode too. So if you have a leak with a identity card, you get a correlation. The one below there, it's a barcode from I did because it was someone selling some reselling for cashing out some Mac, and you basically have all the barcode and the serial number of the equipment. It's simple, but interesting. Another one that is interesting too. A lot of images, and I'm sure you know that beer, that is very common, and they are very active into DDoS activities, but they really like to basically have like images, things like that. If an analyst has to analyze everything, it's kind of painful. But there's something that is interesting, and thanks to the evolutions with all the AI technologies, and especially equipment and hardware for that. So it's not really new. It's basically a combine of neural networks. So it's what we call CRNN OCR. So if you do OCR, you are maybe familiar with that. So a lot of OCR are using a dictionary to find out if it's a word from the dictionary. But on the other hand, a lot of images contain semantic informations, device number, car plate numbers, IDs, things like that, screenshots with some values and so on. Nowadays, with CNN-based OCR, you don't even need to have a dictionary. The text will be automatically extracted, depending on the character set where the learning was done. And you can do correlation on that. So if a word is mentioned like multiple times at different places on different images, you can correlate on that. Easy and simple. So another thing, and this one was a very interesting one. I'm sure that some of you already play with that to classify HTML documents, phishing website and so on. I think you have plenty of research on that topic. We did many research on that. And to be honest, the result usually was like not very good. We even go into like support vector machines, classification, machine learning, and the success of it was like not very good. But sometimes simple strategy works. And this one was super simple. So the idea came from a discussion that we had with a Polish cert about phishing and so on. And they said that, you know, we test many things, but we found out that there's a very simple strategy that clusters a lot of websites. And the algorithm is just below. It's a Python code in ALE for doing the creation of the DOM hash. So the DOM hash is basically a new type of indicator that we created. And it's very simple. It's basically a concatenation of all the tag of an HTML page in the way that it's parsed. So you see we just use beautiful soup, flatten all the tags, and so on. So we don't look at the content, but just as the structure of the page. And this is giving a lot of results. For example, we use it for classifying phishing websites on LuckyLoo, and it's usually very good. Even the content changed and so on, the structure rarely changed. So if you need to classify HTML documents, you can do it. The code is public. We have it implemented in LuckyLoo, in ALE. We have it in MISP as an attribute type and so on, and you can even share it. And it's really, really interesting. So, example, very often you have copycat of Tor onion addresses. It's super expensive. If you want to do clustering, if you use support vector machine on HTML document, you need to use memory, CPU or GPU. It's expensive and so on. You saw the algorithm here. It's super fast on a normal CPU. And in this case, we basically were able to cluster a lot of onion addresses that we don't even want to look at. So some are basically like things that you really don't want to watch. But nevertheless, we were able to cluster those and say, okay, those ones are disambiguous from the analyst perspective, which is interesting too for people that are creating like fake Tor onion addresses and try to mess up with the infrastructures. With DOM hash, we were able to find them quickly. Another one sounds completely stupid, but it works. So this one is based on HTTP version 1. It doesn't work on version 2. It's a very simple one. When you connect to an HTTP server and you get the response back, you basically have HTTP headers. We don't look into the values, but we just looked at the prefix of each of the headers, and we concatenate those, and we do a hash value out of it. That's basically it. So it's really a header hash. It works. What you can see there, it's the number of headers that you can see, because if you use Tor, for example, those header hash are not reordered. So that means the remote server, which is hidden services, will give back the data in the same order. So that means you can cluster all the servers using the same behaviors. It doesn't work in HTTP version 2. The reason is everything is flattened and is basically sorted by alphanumeric sorting, so it doesn't work. But this is really simple, and that's really giving interesting result. Another one, cookie names. If you connect to a server, they give you cookies, for sure. But don't look too much into the value of the cookies, but look at the cookie names itself. I just took the example on Tor. You see that we are collecting around 1,000 on peak time per day of cookie names, which isn't that much. And for example, the two first, for example, one is PHP sessions. So you know that a lot of servers running on Tor are actually using PHP, which is interesting for various reasons. And for correlating. So for example, this one is sticky notes cookies, which is used for Pastebin-like website. You just look at that cookie and you find automatically all the onion associated. It's a quick win. It's not black magic. I mean, it's just like looking at headers, and that's giving some interesting result. Another one, even more simple, file names. And I think this one I was the first to say, don't look into file names, it's generating false positive, it's bullshit, and I was wrong. Sometimes file names are useful. So for example, if you are on a social network or on a leak, the file name reveals a lot of information. This one is interesting. So this one is about caching out, it's a docx. So that document, and you see immediately there which chat were sharing that files, and especially the relationship where the user talking about this. So you automatically know by just looking at the file names, because the file name was like obvious for the one being part of that channel, and you can see that those people are actively working on to cache out activities. Easy, just a file name. Another one that is interesting, I would say like 3 years ago, we were like, okay, Google Analytics tracking users or threat actor with that is like useless. We don't need that. But very recently, we say, maybe we should review our data set and see if it's really useful. So we actually do that. A lot of Tor hidden services actually have a Google Analytics tracking code inside. So you see the distribution of the graph here, it's always constant because we crawl in the beginning of the month, so that's why it's going down. But every month, we basically collect a lot of Google Analytics tracking codes. And some, even ransomware group, for example, reuse templates from block and so on, and they forgot to remove the Google tracking code, which is interesting too. Even if it's not linked to their activities, it's clustering for you the bad behavior of someone, so which is already giving you details too. Thing that is interesting too, it's really a weak, what we call a weak indicators. But nevertheless, these weak indicators can help you as creating a composite way of having indicators. So usually what is good is when you have a set of correlations is to have a set of composite one to validate what you have in correlations. And for example, this one is interesting. So we have this Google tracking code, which is like validating 3 onion addresses, but we see that we have already a suspicion because actually they were sharing the same Telegram channel for those 3, but this one is a weak indicators. But if you have to have like 1 week, an additional weak indicators, title page, then an additional favicon, and the DOM hash is the same for just 2, but not third one, then the combined set giving you a strong perception that we actually have the same kind of threat actor. So, for example, from ransom look, sometimes we were looking at one group, and then we discover a set of new ransomware group by just looking at this. And it's a weak indicator. Another one which is funny. Very often, we have this behavior saying that, okay, cryptographic materials are not so interesting to leak data. But it depends. It depends where the cryptographic material is used. So maybe some of you are familiar with vanity addresses in Tor. So that means people try to brute force the elliptic curve to get a very nice prefix. The problem is sometimes we know the prefix. So if you have a prefix like, I don't know, ransom, we bet it's related to ransom. But sometimes it's difficult to spot what kind of logic they have when they're generating it. So what we did what we call a vanity explorer. With my colleague is a bit creative on choosing the the favicons, the icons. And this one we didn't know about this one, so it's starting with 365. But if you look a bit further, it's 365 CP. But what we did, we split and we navigate through the fingerprint to figure out that this group is basically CP means child porn, so that's actually a group doing child porn. But we didn't know, but by doing this kind of analysis, or just navigations, we reveal some patterns that were interesting for finding out this group. And a lot of groups are doing that. Even ransomware groups are having some unknown prefix for communication, and they keep the prefix for them, but if you want to find it, it's an easy way to find it. It's the same for encrypted messages. Very often we were like, okay, it's not super interesting to look into encrypted messages, but this one was really giving, I would say, very good result. So what we do, and I hope that I won't be killed for that one. So you look at these email addresses, is a Columbia connections. So I bet in which business they are. But you see there, we have a lot of correlations on the key ID, user ID. So they basically have this email address, which is set in a lot of PGP communications. So when you do a PGP message encrypted, you basically leak the metadata. So the metadata are super interesting. And they tend to reuse the same key across services. And if you look at all the galaxy of Tor onion services, communications they have, and so on, you can see exactly what they are doing. Instead of reusing different addresses, they reuse always the same addresses. So even if you don't know what to do with encrypted data, keep those, because maybe in 1 or 2 months, you might discover that there's metadata leaking on those kind of messages. So, and that's what is, I think, the message I want to pass today. So pivoting, usually we want it to evolve from manual to automatic. But I think we still keep a bit of intuition sometimes, because the thing is, indeed, there are rules for pivoting and so on, but it's really depending on your data set. So if you have like threat intelligence with just malware, that makes sense to basically have like specific rules for hashes and value and so on. But nevertheless, for a lot of other data sets, you might have things that are interesting too. So don't hesitate to try to get uncommon indicators. We have a huge list in ALE and MISP of attribute type. Those that are not coming from nowhere, they are coming from different people, researchers that actually use the platforms. It might give you some hint too. So if you have to do investigations, just review the attribute type and say, oh, maybe I should look into this kind of type, and then you can process it. And something that is important too, it's even if the data is imperfect, like we have seen for Google tracking and so on, combining those might be interesting. Imperfect doesn't mean useless, and I think it's important in this case. And going back to that, creativity is still important. So we did the mistake some years ago to just focus on strong indicators that we know, but we should more focus sometimes on weak indicators. So just for the side notes, all I showed to you on the screenshot and so on were from an ALE platform. So it's an ALE platform that we operate and that we maintain. This one was containing a 3-year data set of Tor hidden services and some social networks. If you want to reproduce it, it's easy. You can install the software, collect the data, and you can actually use it. If you have any questions, idea, I'm still there, or just drop me an email. Thank you.
Thank you, Alexandre. We have some time for questions.
Don't be shy.
So
and if you are shy, you can ask me later on, no worries.
One question from my side.
Yeah.
You said you need some kind of intuition to decide which indicators might be interesting. Do you have now a list internally which you say, hey, in this?
Yeah, so what we do, and it was what I was mentioning, so in the MISP we have a list of attribute type, and in ALE we have a list of correlation object. So what we recommend is when you start to do an investigation is to flatten the actual data that you have and to see if you have some data point that might match those attribute type. If you don't, then it starts to be creative and to find those one that need to be correlated. Thank you.
Thank you. So then the next talk is TLP Amber, so please bear this in mind. reached another important point on the agenda, lunch break. We'll see each other back at 1:15, so 13:15. Enjoy your lunch. So welcome back. I hope you have some new energy from the lunch buffet. Welcome to the second last session of this year's first CTI conference. And in this session, we will concentrate on things that bother us every day in our work. The first talk is about setting setbacks into strengths, and is held by Enzer. The stage is yours.
So hi everyone. First of all, thank you for joining to this session. My name is Tunan Dabak. I am solution engineer in SOC Radar, and today I'm going to talk about ransomware resilience and learned lessons from ransomware attacks. So I would like to start with an interesting question. Just imagine that you are a hacker and you have two banks and you will attack one of them. So which would you attack? Can you raise your hands if you choose New York Federal Reserve Bank, if you would like to attack it? Or would you select Bangladesh Bank? Okay, I thought the same. Actually, there was third option for hackers. So they chose to attack for the SWIFT system of banks because they already knew that banks are so secure. So they found a third option, which was actually banking SWIFT systems. And what it cost, basically, $81 million. So this is the case for Bangladesh bank heist. It's one of the largest cyber heists in history. Basically, hackers ordered Federal Reserve Bank of New York to transfer $81 million from Bangladesh bank to offshore accounts to the Philippines. Actually, at the beginning, no one understood. So once it reached to the certain point, which was huge amount of money, $81 million, they understood that something is going wrong, and they stopped the transactions. However, hackers already stole $81 million, so that was the damage. So what I'm trying to say is that it's really important to understand attackers' mindset, because you might think, okay, I have security tools such as CM, SOAR, vulnerability scanner, I know my digital assets, but actually you have to think outside of the box, because that's what threat actors are doing. They are seeing what are your unseen. So it's really important to look in this perspective as well. So I first would like to emphasize the real impact of ransomware. So I have another question. Do you know what is the largest ransom payment ever paid as of today? It's actually $75 million. So it's really huge amount of money. We don't know which company paid this money. We don't know the details, but we know that it was paid, and it is $75 million, and the company was one of Fortune 500 companies. But we know about the second largest ransomware payment. So it was CNA Financial. Basically, a ransomware group called Evil Corp attacked to CNA Financial. So at the beginning of March 5th of March in 2021, they actually exfiltrated their data. Then they basically, I can't. Okay, it's not working. So they basically deployed the ransomware. And after 2 weeks, the negotiation discussions started. And at the end of 3 weeks, we know that CNA Financial paid around $40 million for these ransomware cases, but it didn't end. Then it started recovery stage, as you can see in the in this part. Actually, recovery stage is also important because it has more cost than ransomware itself. Why I'm saying this? Because as you can see, in 2024, average ransom payment was around 1.85 million, but the recovery cost was almost double of it. So you can ask, what is the motivation for companies to pay these ransoms? Basically, it might be related to their reputation, their business continuity, they want to recover their data, they want to avoid public disclosure, and then they pay. But what they don't know is then they have almost 2-3 times higher costs. which is basically incident response, forensics, then legal fines, regulatory responsibilities, and so on. So it is really important to understand that before it happens, we should somehow look in a proactive way for these cases. I would like to show you a snapshot of 2024 about ransomware attacks. So talking about the targeted regions, I can definitely say that last year, Europe and North America was first two regions that got more attacks. When I'm talking about Europe, I can say that first three countries were Italy, Germany, and Spain. And attack vectors, first three attack vectors basically were phishing, exposed RDP, VPN services, and third-party vendor access, which basically was the example that we started today's session. Then I'm going to talk about these cases in a detail, but I would like to also show you that the ransom demands started from $500K to $10 million, and it's basically depending on the company size, depending on the sensitivity of data, and so on. And here you can see ransomware families used mostly during this ransomware. So basically it was Lockbit, Black Cat, and Club. So I would like to also show you projected ransomware damage by almost 2031. As last year, it was around $42 billion. And you can see that in 6 years, it's going to be almost 6 times higher than last year. So it's really huge amount of money just by caused by ransomware damages. And this shows us a number of victims per month. So it's already 3 months past for this year, and you can see that first 3 months it's already doubled comparing to last 2 years. So it's really concerning because it's almost 2-3 times higher than last 2 years. That means that we have to be experienced and learn some lessons from this kind of ransomware attacks. And talking about 2025, first 3 months, you will see top 10 victim countries. The first one is US, second one is Europe, and then it goes Brazil, India, Great Britain. And the reason why US and Europe, as basically Fortune 500 companies are based there, there are more high values, so ransomware groups try to attack these companies. And here you will see overview of the impact on the financial industry. So basically, it shows financial industry, but you can think for general-wise, because financial industry is the first attacked industry. The reason is that they have more value, high access to sensitive data, and of course the amount of data. So you will see that in 2024, almost 65% of financial organizations reported ransomware attack. And that means that there is a slight increase from 2023 in terms of 2021. About data breaches, over the last 2 years, 46 of financial institutions experienced data breach, which is also very concerning. And the cost, again, here, you will see it's increased from 2023 to 2024, and it's going to increase again. Also, another interesting thing is that in 2024, 51 of financial services organizations paid the ransom to the recovered data. As I said, organization, you can ask why they are paying, what is the motivation. Basically, they are afraid of leaking their sensitive data, avoiding public disclosure, and they want to recover their data. So almost half of it already paid for ransomware cases. I would like to also show you top 5 common causes that ransomware attacks happened. First one is the most basic one, but it still works, is phishing emails. So 70% of successful data breaches were reported through phishing emails. That means some of employees, some of us clicked on malicious links, or they just opened infected attachments, and then basically they were infected. The second is insecure remote access. That means that also happens a lot in banking industry. They are exposed to the internet without any protection. So this is something that causes those ransomware attacks. And the third one is lack of multi-factor authentication. Sometimes admins or privileged users don't use any 2FA, and they are just logging through a single point. So that causes also a way for attackers to attack. Third one is unpatched systems and legacy software. Unpatched systems, basically threat actors are trying to exploit known vulnerabilities. So it's always important to be up to date and know the vulnerabilities. And last one is human error and social engineering. Basically, all of us are human. We can do mistakes. So it can be through the misconfigurations. Some of the people use weak passwords. So that's also something that threat actors are targeting and are using for ransomware attacks. So as you can see, ransomware actors didn't use basically 0 days in most attacks. They used misconfigurations, poor access controls, and human vulnerabilities that were completely preventable. So we talked about ransomware attacks. We talked about ransomware statistics. Now let's talk about ransomware groups. So if you ask me what is their first motivation, is of course their only motivation is money. So they don't care about how much data you have. They only care about how much you will pay to them. So they even conduct background research to target companies with high revenue, weak cybersecurity defenses, and of course cyber insurance coverage, so which will make companies more likely to pay. And the interesting thing is that they are like a mid-size or enterprise companies. So they even have HR policies, they even have performance reviews, salaries just like mid-size or enterprise companies. You can see as an example that the country ransomware gang had internal HR policies, performance reviews. So they are not that amateurs, they operate like businesses. And they invest in human resources. So as you can see, ransomware groups actively recruit skilled hackers and penetration testers to improve their operations. So as an example, No Mercy Ransomware actively sought pen testers and promised money as the only incentive for joining. So they offer actually financial incentives and bonuses, which is really interesting. And they don't discriminate when they are choosing their victims. So they don't care about your religion, they don't care which language you speak, they don't care which industry you are at or where are you at. So their main criteria is being able to pay. So, and of course, as I mentioned, if you have weak security posture and high operational pressure, you can see as an example, even charities and small businesses have been hit despite attackers claiming they avoid them. They always do that, but at the end, if they have profit on that, they will attack. And they don't use complex tools to infiltrate. So as I mentioned about the top 5 common ransomware attacks, it's not that complex. Actually, if they are looking for weak passwords, phishing cases, so it's still phishing. Social engineering remains the first attack vector. They're looking for unpatched vulnerabilities and stolen credentials from data breaches. So as you can see as an example, many high-profile ransomware attacks occurred due to unpatched known vulnerabilities rather than advanced zero-day exploits. And it's funny because they also invest in their own security. So just like defenders, ransomware groups try to harden their infrastructure against takedowns. So they use Tor networks, they encrypt communication, they even use commercial cybersecurity tools. So they really rely on their own security and try to improve their own security. As an example, you can see leaked chats from ransomware groups showing them purchasing VMware Carbon Black and other security tools to improve their operations. So they really try to invest in their own security. And they do everything to get paid. So here you will see evaluation of ransomware. It's like a multi-level extortion. So everything started with the encryption. At the beginning, they encrypted files and demanded ransom for decryption. Then they went for double extortion, which means they stole data before encrypting and they threatened to leak it. Then the third stage, basically, they claimed that they are going to do DDoS attacks to force compliance. And finally, they started to reach third parties, customers, to pressure the victim so that they can get their money. They also say that they have ethics, but actually they don't. So some ransomware groups can claim that they won't attack hospitals, charities, or critical infrastructure. However, this is not the case. If it is something very profitable, they will just ignore the rules. So they can say it's just business. If they pay, it's their decision. However, these are their basically ignoring rules. And you can see, as an example, the Conti ransomware group initially claimed that they are not going to attack hospitals, but yet later they targeted them anyway, so because the ransom was high enough. So knowing all of these kinds of ransomware activities and how they behave, it's really important to understand that threat intelligence matters a lot. Actually, leveraging cyber threat intelligence for your security posture is really crucial, because then you can track ransomware groups, you can prevent those attacks, you can protect your digital footprint. And it's also important to understand their mindset so that you can know what are your unseens. So it's very important to use cyber threat intelligence so that you can track their activities. You have the IOCs, you have all the activities so that you can protect yourself. And dark web intelligence basically also often reveals on ransomware gang tactics, tools, and victims before attacks even happen, so you can prevent yourself before it happens against you. And as we started the session with an example of Bangladesh bank heist, its third-party and supply chain attacks are a blind spot. So financial institutions, banks rely on vendors, fintech partners, and service providers, but actually ransomware groups also rely on them. So it's really important to implement strict vendor risk management policies, to monitor third-party access, and ensure partners follow security best practices. So you can say that you are secure, but if your third party is weak, you will be weak as it is. So I would like to conclude my session with $1 million advice. This is actually not from my side. This is actually from ransomware group that gave advice to a victim. So a victim paid, we don't know the company again, we don't know the details. When the victim paid to ransomware group, they gave them the key, and once they decrypted, they got with this message, basically, which says that if they would use something like black carbon, or like if they would use 2FA, basically they wouldn't even lose time to hack them. So this is actually very interesting and true message that is left from ransomware groups. So that's all from my side. If you have any questions or if you would like to talk about ransomware cases, you can reach out to me, or I will be around here so we can talk about that.
Any questions?
So you mentioned that lack of MFA was the #3
Yes.
cause of ransomware. I was surprised that that wasn't higher up, that like an exposed credential without MFA. Can you talk more about how like you might see MFA in combination with some of those other tactics or top causes?
Can you repeat your question? If MFAs?
Yeah, so if MFA, I'll ask a different way. So like if lack of MFA overlaps with any of those other top causes of ransomware.
So basically, the first tactic that were reported from last year was phishing cases. The reason why, actually, those are top most causes that were successfully reported as a data breach. So after phishing, the first two tactics that ransomware groups used were basically phishing and then RDP and VPN access without being exposed to the internet wide, without any protection. By MFA means sometimes when we are using third parties, or like when we are using logging to systems that we have in organizations, if we don't use any multi-factor authentication, if our admins or privileged users don't use any multi-factor authentication, that means with the social engineering or with even phishing, the threat actors can reach to their credentials, and then they can continue to move laterally in the systems if there is any multi-factor authentication. So it can be considered only by multi-factor, but it can be considered with the phishing and the other cases, because this is like a social engineering, so threat actors can move laterally through the admin's accounts or privilege access accounts as well. Yeah, so if you have any other question, or like if you would like to chat again, I will be around here, so you can directly ask to me. Yeah.
Thank you.
Yeah. Thank you.
Then in the next talk, Jake will talk something that we never heard of. Everything is priority.
All right. Make sure that doesn't fall. Okay, so thanks for the introduction. Again, if this works, please. Oh, no, back. There we go. Anyway, so yeah, again, I'm Jake Nicastro. I'm a tech lead on our frontline Intel operations team here at Mandiant/Google Threat Intelligence Group /Google Cloud /Google / whichever brand you want to use. There's 3 of us here today, and we chose a different one for each of us. So yeah, whatever you want to call it. But anyway, coming up on 7 years at Mandiant, I started with the company as an incident response consultant, so doing all the forensics, working with clients in some of their worst days. A few years ago, I switched over to the Intel side of the house, but didn't go too far. So the team I'm on, I mean, kind of by the name, it directly supports our frontline teams, which is incident response and our managed defense team. And so we're focused very much on the tactical level intel with everything going on that we're seeing in the front lines. I also have a little over 7 years of experience with the US Army, most of that doing the most Army thing you can think of and the least cybery thing you can think of until the last year. That might seem irrelevant, but I promise you it will be in a moment. And then as an aside too, half my time as of this year anyway is spent doing AI research for my team specifically. So if you want to talk CTI and AI stuff, happy to do so. So yeah, this phrase, we've all heard it. If everything is priority, then nothing is priority. This kind of actually spurred from a discussion I had last time I was at First, which was in 2022, and kind of was related to the talk I had at the time, which was a little bit more related to dealing with overwhelm and CTI, and just dealing with the kind of the mental health side of that. But this phrase had come up during a discussion, and I remember I frankly disagreed with it at the time, and the more I've heard it since then, the more I disagree with it. So today I kind of want to challenge that notion of if everything is priority, then nothing is priority, because I don't know if that's actually the case. So at least come in with an open mind today and maybe just look at this phrase a little differently. Maybe I'll have you convinced by the end, but we'll see. So we're going to start this off with a little bit of a story. This might be a flashback for a number of folks in here. So this was July 2021. For us in the US, that was going into 4th of July weekend or Independence Day. So looking forward to a holiday weekend with hot dogs and fireworks and all that stuff. But then news started to roll out that a certain IT product was being used to potentially deploy ransomware. Specifically, it was REvil or Sodinokibi, whatever you want to call it. And at the time, of course, that might be starting to get some attention on social media, early reporting. Leadership starts to care about that, be like, hey, what's going on here? Do we have to care about this? And it's kind of a little bit of a rising tide of chaos. So one of the things we did, though, it was not do the typical, like, hey, shiny new thing, all hands on deck, blah, 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 it's a new priority, we're all going to focus on this now. No, because so in this situation, we were grounded by one of our team leads who I think did the right thing, which was pump the brakes of the whole team. Stop, take a breath for a second. Let's assign someone to at least assess the situation and kind of lead this like response. If I'm going to use that word a little loosely, but at least figure out what's going on. Maybe identify a couple other people to support, but otherwise the rest of the team should continue doing their mission. And I say that because, like, so this is kind of our perspective from our team within Mandiant. So, like, I've got this Our Evil event going on. I kind of ended up being the lead just because I ended up stumbling on the news first. How dare I check Twitter? But so I've got this Our Evil event going on. But at the same time, the rest of our team, we still have all these incident response investigations going on. We have our managed defense customers to keep track of. And these are all priority to them as well. Like, we can't just give up on our clients and be like, oh, sorry, this new thing's happening. We're not going to care about your investigation anymore. Or we can't just give up on our managed defense clients who are paying us to watch their environment and keep them protected. But we also can't ignore that Our Evil event. And all of these things are a priority to someone in some way and to all of us in some way as well. So it's kind of more, how do we deal with it? And this is kind of where I started to connect the dots in response to this event. So again, this is where I'm going to start pulling from some Army stuff. I know that cyber or military connection can kind of be sometimes contentious, but fact of the matter is we at least do draw some concepts from military and defense industries, at least especially within Intel. So maybe a little less spicy here, but I'm always a fan at least of, I mean, doing this myself, but I love hearing other people draw lessons from completely unrelated fields and have that like transfer knowledge. So I was at least amused that my brain made these connections, so I wanted to talk about it. So, if you're a tactical nerd, just for reference, these two books are publicly available. This is a field manual on how to run an infantry rifle platoon and squad, and then this is the U.S. Army Ranger Handbook. Both are publicly available if you want to dive in. The U.S. Army is really, really good at documenting absolutely everything, to the point of, like, a couple times I did this as a joke, but it was dead serious. This is a thing. If we were doing a little lesson, just a refresher on like hand signals, such as like, I don't know, freeze or like ceasefire or whatever, they're straight up with visualization or illustrations and description and everything. There's a description of the like acknowledgement hand signal, which I would describe as like putting your hand forward, making a fist, and then your thumb to the sky, and congratulations, you did it. Like genuinely, there's step-by-step on how to do a thumbs up. So we're talking that level of detail. I'm not going to go into that level of detail, but just as an aside, it's amusing. So, again, continuing on kind of the way we responded to this Our Evil situation, balancing priorities as a team. So this centers around this concept of this patrol base. Don't have to worry too much about it. Long story short, it's like if you're out on a mission and you need to halt for, I don't know, a couple days max, it's just kind of a quick way of like, hey, let's just establish a little base of operations. We're not going to build anything necessarily. We're going to set up this kind of triangle formation. You've got all the little dots. Just imagine those as little troops. And then like on the corners is like machine guns for protection and everything. But the way it works when you set this up is you assign these like sectors of fire, or fields of fire to every single troop in that little triangle. Chart's a little bit of a mess. It's rough. It'll get easier to see in a second. But the point is, like, your job as that troop on the line is like you're responsible from wherever your lead tells you, from like this tree to this tree, and that is your world, and that is all you are concerned about. And you do that for everyone, including the machine guns who have just like this larger protection, which is like stopped by that yellow line. But anyway, so where this comes into play is, so say, okay, you're hanging out, and then there's some activity down here on this lower left side. The red, just imagine it as, I don't know, enemy, a threat, or whatever. So in that area, that's at least now the concern of those troops on that line. It's probably also a concern of leadership, too. It's like, okay, they have to keep track of the whole unit. There's at least some threat out here, and part of our unit is engaged over there. But imagine you're this dude on the top line, or girl. Finally, the US Army allows women now in infantry. But imagine you're this guy or girl on the top line, and you have your job of taking care of that field of fire that's to like the north there. You're going to hear this commotion going on to this lower left. That lower left, again, is a priority to those troops over there. It's a priority to leadership. But your priority is also what's in front of you. Because if you start turning around and start checking out and want to respond to that, two things can happen. One, you are endangering your teammates who are now in front of you if you're turning and looking that way. And this is an extreme scenario, but I liken this to the fact where like we have had similar situations where it's like, oh, another shiny new thing, all hands on deck. And people start tripping over each other, not literally, but in the way that like redundant workflows might start to happen, communication breaks down, and that just ends up having compounding effects and kind of makes the response worse as a result. Secondly, though, you're now not watching your sector, and you're not doing your job, and that is now a weakness to the rest of the group. So it's important for that one individual to maintain their priority, because that priority still matters, even though there's this other stuff going on. So this comes to the first lesson, which can basically be summarized as like addressing the current threat or current task, current whatever, as a team, and maintaining the security of the rest of the team in this case, or just continuing your general mission as a team, can both be priorities. They're both priorities to someone. They can coexist, and that's okay. So that was on a macro level. I'm going to bring it down to now like an individual level, and I'm going to use this like rifle range as an analogy. So every year in the Army, like you qualify on your rifle to make sure you can you're at least halfway decent at accuracy. And the way it looks is like you just have this line of just open terrain in front of you. These targets pop up from these berms, and your job is to just knock them down. Another way of looking at it, and I'm going to use this way just for the sake of the presentation, is using this little paper target, which has the same like targets at the same like imagined distances, so you can practice on it that way. So I'm going to use this for reference for this set of visualizations coming up, but just imagine it's the same thing. Imagine this last image here, but with like the silhouettes of those targets. It'll make sense in a second, I hope. So using my lovely PowerPoint graphics, just imagine this is the range in front of you. So the thing with the rifle qual is you kind of just treat it like a game, where these things pop up. You've got a limited set of time and rounds to knock down these targets. The other thing is each of those targets is timed, so there's a little bit of a strategy involved. This frontmost one, this 50-meter one, is going to pop up for like a couple seconds and go back down. If you miss it, sorry. Meanwhile, the one that's way far out there at like 300 meters pop up for like almost 10 seconds. So you have some time to kind of like, I don't know, deal with some other things, or just time to focus and think about that one a little longer. So putting this into practice, let's just imagine like you have some free time, task pops up, that's a priority for you, cool, we can tackle it and knock it down. But imagine now a scenario where now you've got 3 tasks tasked for you from maybe different leaders or from the same leader, and they're like, hey, all of these are priority. And it's like, okay. But at least in this case, you can assess like, okay, what is the urgency and the criticality of each of these priorities, and kind of go from there. So you kind of end up making like your own little hierarchy. So even though they're all priority, you kind of make your own little hierarchy. So I'm just going to lighten the farthest one for the sake of visualization. So in this case, we're going to address that first one now. Like that one is the most immediate threat, or most immediate due date, deadline, whatever. So we're going to tackle that, and then we can move to the next one, and then we can move to the next one. So we got that first one down. Boom, now we can focus on this one, and so on. Another way of looking at this, just to maybe help visualization, is kind of looking at it like a stack of priorities. So this is, again, the same 3 tasks or whatever that I just had at a distance, now just on top of each other. We can tackle that one, and boom, now we can finally move to this next one, and we can finally work on this third one. That said, I do acknowledge that real life is not always linear like that. It's not that simple. Again, also this is just kind of a baseline frame of reference. I'm not trying to have like all the answers here. So I acknowledge nuance exists. And so just to kind of illustrate that, let's say you are working on that last priority, that one that's been out there for a longer time, because you've assessed you at least had more time to tackle it. And then, oh, boom, new thing pops up, another R-Evil event or something. Like that becomes now your new priority. And so that one you were working on, got to put that aside. Now we got to pivot and refocus on this newer, more urgent priority. So it's about managing the expectations around responding to these priorities. So addressing that hot new thing, but also addressing the existing priority, not totally forgetting about it. Both of those can be priorities, and they can coexist, and that's okay, but it's just a matter of trying to assess which one's more urgent, which one's more critical, but also communicating that with your leadership. We're all human at the end of the day. No one can argue that. We can only work on one thing at a time, so if we have to put this other one aside, that doesn't mean it's not a priority, but like, hey, if you can justify, like, I have another week or a few weeks or months to work on this versus this thing that needs to be done now, then that might be the way to do it. So as far as managing that balance, this is, again, kind of focused on individual level, kind of a team level. There are different tools you could use to try to manage that. So I'm just going to give one today. At the end of the day, it's all about finding what works for you, whether it be you at an individual level and managing just like your day-to-day tasks, or even just like what's going on in the industry versus what's going on at work, or at a team level. So if you've not heard of this is called the Eisenhower Matrix. You might see it in different colors or different words or whatever, but the long story short with the Eisenhower Matrix is there's two measurements, and it's either important or not important, or urgent and not urgent. And based on the combinations of those, you get different actions. So if it's urgent and it's important, you should probably do it. If it's important, it's not urgent, schedule it out. You can probably get to that in a little bit. If it's not important, but it is urgent, if you have the ability to, it might be a good idea to delegate that. And then lastly, if it's not urgent, not important, in a perfect world, don't even worry about that task. For reference to, it's called the Eisenhower Matrix because I think it was at least, I don't even know if this is 100% true at this point, but it's at least attributed to General Dwight Eisenhower, who led the Allies in World War II. Now, again, I understand real life is not always that simple. I wish I could just forget about tasks and just not care about them, but that's not reality. So I've kind of adapted this a little bit to myself, and this is kind of how I end up managing my tasks and my priorities. So I look at it of like, is it important? Is it urgent? I'll do it now. If it's important but not urgent, I'll do it later. If it's not important or not urgent or whatever, I kind of merge these two, and I end up kind of playing it by ear on that one. Or for me, if it's not urgent, it's not important, I'll just add it to a backlog. I don't necessarily forget about it, but like, hey, if I have some time later on, this isn't a rush task. There's no due date on this. This is a like nice to get to. And I'll create a backlog. So I don't even use this like grid anymore either. I kind of just table it out. So I kind of have, this is a really nice version. My version of it is just a scratch pad, but this is effectively what it looks like. I kind of have just like 3 rows, and I have like my important urgent tasks. I have my important but not urgent tasks, and then just kind of everything else. So these are just example tasks here, but like these are genuine things that I'll have on my list of things to do. And like, for example, this proposal doc for a project might be an organizational top priority. It's tied to our like organizational P0 OKR for the year. It's a priority. But if I log on that morning and I've got a bunch of messages from consultants who are doing an IR and they found some spicy stuff and they want answers and they want to have pivot and attribution on this threat, that is immediately now obviously my more urgent, more critical priority. And it's a top priority for the customer too. And the customer in my case being consulting, not necessarily the end client, but don't worry about the details there. But long story short, both of these are priorities to someone, and they're both a priority to me in some way, but I just have to kind of navigate when I'm going to tackle these tasks. And then say like this performance review thing, like, okay, end of next week, come next week, like if I'm looking at this on a Wednesday and it's due next Friday, like next Wednesday, I'll move that up to the more urgent, more important bucket, so it kind of gets to the top of the list. So they're not necessarily fixed in those categories. You can kind of move them around too. again, this is just kind of what worked for me, and this wasn't even a like, oh, I looked at the Eisenhower matrix, and I'm like, boom, I'm just going to fix these things together, and now it works for me. Like, this was a couple iterations of like, I'm not really using this feature, or like, I don't know. It was just kind of iterations over time, and I found out that's what worked for me. But yeah, so looking back at our range example, and how this kind of works. So say I'm working on this priority out here. This one is doing fine. My life's great. And then, oh, another one pops up. Now I got to shift again and focus on that one. And that first priority might have been in that first bucket too, but this one I've now assessed is a little more urgent, a little more critical. I've forgotten about that other one. That other one is still a priority to someone or some organization or whatever, and a priority to me in some way. Now I just got to organize those priorities. So addressing the unexpected, more urgent thing and the existing priority, both priorities, that can coexist, and that's okay. Again, it's just a matter of how you manage those priorities based on criticality / urgency, and just communicating that effectively with your leadership. So again, just to refocus, like every one of these tasks is technically a priority to someone. All of these can coexist. Everything is priority on this board in some way. Maybe not the backlog, but everything, at least in these first two buckets, is a priority to someone in some way and a priority to me in some way. They can coexist. That's okay. It's just a matter of how do I go about doing those. So revisiting this phrase, I don't know if you agree with me at this point, but I would like to challenge this and say if everything is priority, then that's okay. It's just a matter of framing that challenge and framing that scenario so it makes it approachable, because we can say everything is priority, then nothing's priority, but like that doesn't change the fact that everything is still priority to someone. So we can complain about it or we can address it. And if you can find a way to address that and manage it for yourself, for your team, whether it be your day-to-day work or just having to figure out like, oh, is this new thing happening in the industry relevant to me? Do I have to care about it or not? However you apply it, doesn't matter, but at the end of the day, there can be multiple priorities that can coexist, and that's okay. So 3 takeaways, 3 lessons. Again, multiple priorities can exist at the same time. That's okay. Managing expectations is probably the key, I would say, slept-on thing that is kind of the linchpin to everything. So you can have this acceptance of priorities, or you can have these mechanisms to manage your own tasks, but expectations and communicating those with your leadership, again, that you're only human, you can only do one thing at a time. You might be able to divide your work, but you can still only do one thing at a time. And working with your leadership and just trying to communicate that best you can is key. And then on top of that, again, I showed the Eisenhower matrix. That's just one of however many tools that are out there to try to manage tasks, whether it be a to-do list or managing priorities like this. But I found an evolution that works for me. Everyone's different. And for what it's worth too, like I have ADHD, so I'm really bad at dropping tasks sometimes, and that helps me. So everyone's got their different ways of their brains work, so I get it. So find a method that works for you, and hopefully that can help out. But yeah, that's all I've got. So I appreciate everyone listening, and then I'll take time for questions if there are any. But otherwise, thank you.
Thank you. Any questions?
Hi, thank you for your presentation. I was wondering, have you encountered any trouble with prioritizing your priorities when you have a shiny new one, which maybe you don't have to do that fast, but it's shiny and new, so people want to do it, and then it gets to the wrong point in your prioritization, or how do you deal with this?
So are you asking like if it seems shiny and new, but like it's really not that urgent? Is that kind of what you're saying?
Yeah, people are like, oh, this is new, cool, I want to work on it, and then it's like maybe your other work is more important.
Yeah, no, it's a good question. I think obviously every situation is going to be different, and at the end of the day, it's like it depends. Quick answer, I would say, is it's just a matter of like just taking that quick second to at least assess the situation, and like if it's a vulnerability or something, like is this relevant to me? And I guess for example, like I don't know, there's been plenty of times where like some news cycle is rolling with some new vulnerability, and I'm looking at it and like I don't care about this whatsoever until we see a customer roll in with this thing, and they're like, otherwise it's a waste of my time. If someone else has free cycles to look into it, cool, and figure out, like, is this a thing we should even be prepared for? That's great. Depends on how many resources you have, but at least taking a couple minutes to even just assess it and figuring out whether it's relevant to you, I'd say, is the first step, and then going from there. Again, yeah, it totally depends at the end of the day on resources and who's asking, but that's hopefully somewhat helpful.
Any other question? Then one question from my side. Have you also discussed this within your team? I mean, so now you have a solution for you, how you prioritize your tasks and what's about the team around you?
Yeah, so it's a good question. So I would say at least within my immediate team, so referring back to that story, like we've at least got a culture baked in where like we're pretty good about keeping each other in check. We're like, hey, if this thing's popping off, okay, so-and-so's on it, still focus on your thing. As far as individual task stuff, I mean, we just kind of leave that up to like I said, everyone's different, so however works for you. There's some built-in like task management tools at work, or if you are like me and just want to write them down on a notepad and scratch them out or move things around, like that works too. So individually, it's kind of up to everyone, but at least culturally as a team, we fostered this environment, and our team leadership reinforces that too, that like no matter what's going on, we still have to also do our primary mission, and making sure those things are not dropped. So it's kind of years of culture built onto that. Hopefully that answers that.
Okay, thank you. Then we're at the end with this session. We have now a networking and coffee break until 2:45, and we'll then start with the last session of the day and the last session of this conference. So see you back in, plus or minus 45 minutes.
German. I always start early. The clicker is here. Okay, welcome back to the last conference. Now I'm very happy that we have someone from Norway here, and he will talk about Admiralty systems to be used in CTI. Freddy, the stage is yours.
Well, thank you. Let's see again. Thank you. Yeah, there we go. Thank you so much. Well, this is the last session, but not the last talk. I think there's 2 more talks after me, but what we'll do and see if I can do some interpretive dancing and keep you engaged for the next 30 minutes. Yes, I'm going to talk about Admiralty system or Admiralty scale, if you will. Talk a little bit about what the problems are, how we can use it, I mean what it is and how we can use it. And then at the end, try to at least look at this case study, sort of, if you will, and have you guys be involved a little bit of how you would rate some information about the Ticketmaster incident we saw last year. And then some sort of conclusion, and if you have questions at the end, we'll do that, of course. Sounds good? Let's do it. So first, a little bit about me, of course. I work at what's called the Nordic Financial CERT. It's a non-profit. We are working for we're like a sector CERT for the finance sector in the Nordics. So we service 5 countries, Norway, Sweden, Denmark, Iceland, and Norway, of course. And I have about 240 or so financial institutions that I work with, and we try to apply intelligence methodology in all we do. So 50% of my time goes there. The other 50%, I do a PhD at the Norwegian University of Science and Technology, or in Norwegian NTNU. And there I research how can we apply intelligence methodology into CTI, and then how will AI change how we do intelligence analysis, and thus how will that also improve or change how intelligence can support CTI. So that's the gist of my research. I'm also, some of you have probably seen me walking around with a smile, little tag yesterday, and cameras and stuff. It's part of my podcast and research, and I'll talk more about that later. In general, there we go. So last year, Joe Slovic stood on stage, and I was almost flipping the table because he made a claim and said, CTI is all technical because it's cyber's in the name. Well, the other side of it, the CTI, the intelligence part, well, that means intelligence is what it is. But I think we're both right? We're trying to talk about cyber threat intelligence, which are 3 different concepts into one. And those are the things I'm going to focus on is more of the I part, the intelligence side. A lot of the things we see is problems with how CTI people do intelligence. And sometimes when I read reports, I sometimes feel like it either came in a dream, or if it's somehow something is like, trust me, bro, and I can't trust people when I read intelligence. When I read your reports, I need more information. And one of the things that I see often is that when we see all these blogs, they're full of screenshots, and it's a malware, how that works, or how a dropper works, and all of those things are beautiful, right? But the point is, when we look at all those things, I, as an analyst, I have to be able to go back and backtrack. How did you get to your conclusion? I need to know the sources. I need to know the information. I need to know how you assess the sources and information so I can assess whether or not I'm going to trust your information so I can use it in my analysis. Does that make sense? So when we write all these reports, we actually have to communicate in a good way. How did we get to the conclusion we did? What were the sources we used? What is the logical process that we're using to this? And then, how is that affecting all of us, right? You can structure it in certain different ways, but that's usually what I like. I like to see a clear structure. It should guide me as a reader and figure out how did you get to your conclusion. And some of the huge or big issues, right? It's the transparency. I just covered the first part, the transparency. I need to understand and know how you got there. I also need to understand the argumentation. Some things are arguing for your conclusion, but we also need stuff that argues against, which is, it makes sense, right? These things are what we're seeing. Because of that, they could also be X, Y, Z. However, the evidence point to, etc. Those are the things that you as a CTI writer need to include. And the logic needs to make sense. If it's illogical, you're going to lose the reader. And specifically someone like me, when I start writing reports to senior management, I have to see that there's logic and there's transparency, etc. Otherwise, I will not trust the sender. The whole trust me is insufficient. Now, I'm going to talk a little bit about certain things later on, but yeah, I'll use that example later. We'll get to it. Okay, so I covered a few things already. I need to understand what you're trying to convey. I need to understand what you're basing your assessment on. That is the basics. And when you make assessments, they are, of course, built on data. It's built on information. It's built on you and your team's knowledge, or even knowledge from other teams that you collaborate with. But all of those things I need to understand as a reader. You need to also demonstrate to me the trust you put into your sources, your data, your information. When you do, I can then look at your data and how you assessed it and then go, okay, I get it, well, how that person got to that. I might not agree, but at least I can use the source in a good way, and then I can use it into my reporting, and then make my assessment on you as a source. Now, this is an old meme. For those of you who are old, like me, you will understand who Baghdad Bob is, or, Baghdad Bob is sort of the thing. I think Comical Ali was also another name he had. He was infamous during the first Iraq war. He was the information, he was the Iraqi information minister. And he was infamous, and the reporters were laughing as they were filming it. He was screaming, "There are no American troops in Iraq." And there were Abraham's tanks rolling behind him, and there were Apache helicopters hovering over, right? There are no Americans here, right? So it turns into a farce and sort of a theater and a spectacle. But then there are no war plans in Signal, right? You get the idea. When you have sources that are lying to you, you have to be able to make an assessment on the source of the source credibility and information validity. You have to do those things. And then, of course, you have, Oracle. There's been no Oracle breach, right? Or there has been no breach of the different systems like Snowflake we saw. They all denied it. But then we got all the data and we figured out, well, maybe that isn't true. Maybe it did happen. So it creates a lot of problems for us when we try to do this. And then I'm going to call out CloudSec. They wrote a really good report. Everyone thought it was a good thing. But then we started to looking at the data. There's something off here, right? We couldn't quite figure out what it was. But then another user on LinkedIn, and sorry, the reference has fallen out, so I'll see if I'm going to fix that. But the guy said, listen, these are the things that we can prove we know. That's the part on the left side, the confirmed. Partially validated is the next one, right? There are some claims. We need to be able to validate that claim. If you don't tell us how you got that information, we have no way of validating that. So we had to validate. And then the next two on the right side, you see confirmed for both of them, because we were able to backtrack and find data. We found some screenshot on a server, etc. Right? So we were able to go back and actually dissect the report that was written, and then start challenging the claims made. So we can go back and say, okay, so these facts or this part of the report is validated, this is not. That is really important when we start our assessment of sources before we start writing our analysis to whoever we're writing for. Now, when we look at claims like this, right, whoever makes these claims, they own the narrative. They own it. If they say that I have data on this organization and they post it on some forum, there's a ton of people who go, oh, shoot, is this true? How does that affect us? We start writing about it, we start publishing. But it's their way to sometimes just bolster and try to make themselves more reputable, I guess. To try to gain some sort of credibility, or it might even be, as you can see there, drive attention or get something out of it. But the issue is chaos ensues. And then we have all the different vendors, and then everyone needs to be first. And then we have all the researchers, and everyone needs to pile on to that one claim that nobody has verified. Isn't that a problem? Shouldn't we spend some time to figure out if that's actually true? And if it's not true, or if we're not sure, should we all jump on the bandwagon and create chaos? Remember, the point of intelligence is to reduce uncertainty, not feed it. But if we're part of the problem and just jumping on, we need to be more critical. Intelligence analysis is about being critical thinkers. So we have to challenge the prevailing whatever people are claiming and say, what are you basing that on? What are your sources for this? Can you demonstrate to me how you got to that conclusion? Those are the typical questions we can ask. Challenging that and being or disagreeing is not hating. It's actually trying to get to the core of the problem so we can move on with it, right? So, unverified claims, they spread, and there's a huge dumpster fire in the middle of the ocean, right? We have these issues going on. And everyone is just eager to break the news, and they want to be first, and they want to be important. But let's try and step a few steps back as a community and try to make this more relevant to the stakeholders. Because it's going to be really, really hard, and it is sometimes. It's hard to separate the facts from the noise. We need to be able to identify what are actual facts, what are opinions, and what is then assessments, and how is that connected, i.e. the logic. That's what we're trying to do. A lot of the times then, we have what's called a bias, right? We want it to be true, or it's a bandwagon effect, which is what we see often, that everyone just piles on. So we need to be able to reduce that. I'll get to that in a moment. So we should, as I said, talk about the critical thinking. Engage the slow mind, the type 2 mind, rather than the rabbit mind. We do the tortoise mind, to go a little slower so we can actually go through how did they get to this point, etc. We have to focus on the critical thinking and also apply SAT, structure analytical techniques. Those are meant to externalize our thinking so we can talk to others and say, hey, these are the things I'm thinking. This is the way I think it's connected. It's based on this. And when someone listens to you either drawing furiously on the board or just explaining or you're discussing, that person goes, I hear what you're saying, but how about that? Or what about this? Or missing that? What about that source? And they go, oh, okay, yes, this, that, okay, that missing. Then you start collecting to actually start building your case. Of course, there are times when time is of essence. We don't have time to do it, but then you have to make that explicit. We have not assessed this source, or there are doubts about the validity of the information. We have to be clear on this is what we know, this is what we don't know. We have to point to those two things and make it clear that those are two different things. Sometimes we read reports on really shaky ground and foundation when you start looking into the sourcing, right? So Sean O'Connor and me, we wrote a blog on SANS. If you search SANS on Admiralty scale, you'll actually get the blog, and it goes through all the things I'm talking about now, but a little bit more depth. I only have like 17 more minutes to talk about this, and I could spend the whole day talking about this. So yeah, somebody thought it was a good idea to put me on stage. The first part is, where does the Admiralty part comes from? It's actually back in English, it's the 20th century. To me, it's the 1900s, so early 1900s. The need from the Admiralty, when they have all these ships outside, they had to get some information back to figure out where were the conflicts, where were the different issues they had to deal with. And they could get information from sources weeks or months or even up to a year about the same situation. They wanted to find a way that they can standardize the communication, so when someone said this is an A1 or a B2 or a F6, everyone agreed that that's what it meant, and the underlying, the way you're supposed to use those numbers was commonly understood, so you can get information from multiple sources over a long time, and then you can actually assess the validity of the information and also the sources. The Admiralty scale has been used by the intelligence community in many, many, many years, and they're using it actively to say to the reader, first here's the data, and then these are my comments, so the analyst comment, and commenting on the sources and the information if there are some dubious claims or someone is challenging the claim by the source, we have to make that clear to our readers. And it's sort of a BS detector, right? We try to figure out if this is a lie or not, if someone's trying to brag or not, if this is actually true. We have to be really hard on assessing the sources. And we have to figure out if the information is genuine, if it's actually what it says and states what it is. If you want to read the blog post, you can actually go and use this QR code. Trust me, I work in cyber. But the whole URL, you can find it there, because I'm going to ask you some questions in a couple of minutes. We're not going to use some digital things. I'm just going to ask you guys to raise your hands and see what you say. But this is the scale in itself, right? On the left side, you see the source reliability. That's only about the source. And on the right side, that's only about the information. We separate the two, and I'll talk more about those things. But when we do assessment of sources and information, we have to separate the two. And as I said, I'll talk more about it. We also use A1 to F6. So A1, A is like you have the source, you trust it, you've used it continuously, that source has always been true. And 1 is the information can be verified and is valid across multiple independent sources. You can't use a source that's looking at the same as another source, but looking at the same portal with the same chat log. Those are not then two independent. You're using the same source. That's a really thing I wanted to highlight. So when we look at the source validation, as I said, the source reliability first, that is the trustworthiness of the origin, i.e. the source. That could be a log, it could be a profile on X or on some forum, it could be a blog post and the writer who wrote the blog. That's the source, the thing, the entity, the person, whoever who wrote the data. Do we trust the data or not? Like an example I usually use is, can a threat actor change the logs on the system? Everyone agrees, yes, they can, right? So should we then trust the log, without any question? Well, that depends. We have to do some research to figure out if there are any dubious other information in other logs to see if that's been going on, but that's a different story. The last point is we evaluate the source independent because the source might be really good at malware analysis, but has no clue about COVID-19 or about Signal or war plans. So if some people are really good at one thing, that doesn't make them automatically good at everything they post. So we have to assess the source based on what they're talking about and what they're normally able to understand and should be an expert on when you start verifying if that person is good when they talk about topic X, Y, Z. Now with the numbers, oh, sorry, I forgot to say one thing. Let's see if we can get this to work. Yes, we do. So with the source reliability, I said it's A to F. It's like they're completely reliable. As I said before, that's the person or the source that we know, we used multiple times, and we're really safe and comfortable with trusting that source. A1 is something we seldom use, but I'm going to demonstrate an example later. But you usually don't see it. You really, really need to trust that source for that to be reliable at all. But that's a different thing. F6, usually we say the F part is when we haven't been able to or don't have time yet to assess the source. So that's used all over a lot of the time. Again, in the Cura code, the whole explanation of all the different both letters and numbers are explained with cyber examples. So you can use that as a way to sort of look at what all this means. Went to. Okay, so in the information, as I said, we look at the information alone and not with the bias of the source. Confirmed by other independent sources, that should be part there, but when you read it, what's in the blog, it's highlighted and specifically declared that you have to have independent sources. And on the end, you have truth cannot be judged, or I haven't had time yet, but I will later. If this case I'm working on with this source is important, and I have to make that assessment. The point here, again, the last one, is that we look at the information, whether it makes sense or not, for us to be able to trust the source and trust the information when we write our own reporting. So this is an example. I'm going to give you an option or opportunity to just read the text. Based on what I said, is this an F6? Anyone? Yeah? 10 minutes, thank you. Maybe it's a A1? Oh, okay, happy. This is an arbitrary thing, right? I'm giving you an example, I'm painting a picture sort of to lead you away. Some would say this might be a B1 or a C1. It depends on your individual experience with that source, but the way it is explained, you have multiple runnings with this source, you have used it multiple times, you trust the source with this specific piece of information. And that information has been confirmed by multiple independent sources. That's a good thing. Next, I'm going to let you read again. Anyone want to shout out like an example? I'll wait. I have 9 more minutes. So how about E4? Anyone have the same? It could be like a B4, C4, but again, it depends on how you interpret the source and how you use it internally. I would personally give it an E4. Simply because of the things you read here, and you can start ticking off boxes. I've written it specifically so it matches the description of the A to F and 1 to 6. Last one. This is what we often see when we talk about forum posting. And this is actually a description of a case that we worked on to try and figure out what claims have been made by this person. And if you know how forums work, you know that if an admin supports this new user that you've never seen before, and another independent user that's usually a mod or something higher with high reputation also supports the user, it sort of gives a little bit more validity to the source often. But at the same time, I don't know the person, I don't know the profile, and I haven't been able to confirm the information in any way, shape, or form. So to me, until I get more proof, this is a D6. So I don't have an ability to verify the information. That's the 6. The D part is, it's not an E, but it's a D, right? Because it has some legitimacy, because of the support from other famed users, I need more data before I can bump it up. So this would be a typical case where this happened, right? So the Ticketmaster case and the Snowflake breach, where someone made a claim online, and when we scrape that, we can put it into a table whenever it starts to move. I'm going to click like 3 times now. Let's see. Oh, there we go. So highlighting here, right? The first time I read it, I'm like, this is F6. I have no idea, no way to confirm this claim in this source. And I'm trying to track the username, the timestamps, how often this person has been online, how often this user has been claiming things, do you have some sort of credibility score? All of these things count when I do this. So this is before I started doing my analysis. But at the same time, I mean, a couple of days later, there was a different user posting on a different forum and actually talked about different things, right? So now we know more. I'm now able to, this user, I've known. I've seen this user multiple times, and usually is good at actually being true, I mean. So to me, that's the B3. So it's possibly true, but I'm still missing more information, and I'm not trusting it because it's still a forum. I have no idea who the person is. It's just a handle, right? And then there's another post a couple of days later again about here are some examples that you guys can look at. Again, I'm looking at it from that user perspective. That specific user I have never seen before, but it's starting to confirm other things, but still, that user needs to be assessed on all the other information I see on that forum, and now I start to see connection between this user and other user profiles on other forums. I'm starting to connect. I'm starting to suspect maybe this is the same person or same entity, if you will. And then again, there's more. Now suddenly there's 30,000 Ticketmaster examples that people can start looking into, again, to prove their validity. And again, I'm starting to look, okay, now we're getting somewhere. This user profile, seen many times, is supported by admins and also other people with high credibility on the server. So now, to me, I'm looking at, well, this is a B2. Now I can start working. So how do we determine the reliability? Well, we use SATs, the structure analytical techniques. You use these without, I don't think you realize that you're using them, but you do. So for instance, timeline. We've seen examples of timeline over the last 2 days. We also looked at mind maps. I showed it as well, right? We have concept map, argument maps. All of these things are techniques in SATs. It's a way to externalize your thinking and have that little sanity check or rubber ducking, if you will, with a colleague that you go through everything and they can challenge your assumptions and challenge your biases. One of the biases is accepting data as true without assessing its credibility, and that's exactly what we're trying to reduce. With the timeline specifically, that actually addresses that. We'll look at the data. How does it conform over time? How does it fit if it's different user profiles? All of those things we can start mapping out. And as I said, with this link analysis, we try to make we try to understand the mess that someone has pushed out to try and figure out how does that help us? How is that source reliable to us or not? So, with a couple of minutes to spare for questions, basically, we use the Admiralty scale to do assess the validity and trustworthiness of sources of information. If you're going to do it, start small. I know that the vendors are using it, like I think Intel 471, for instance, has it in their portal. I know that it is in MISP as a function where you can add the Admiralty scale and actually put it into sources and data as you work with it. And then you want to try and find alternative explanations. This is the core of critical thinking. That's what you're trying to do. But the thing is, I think the last point I'm going to do is the caveats at the end. If all of you start adapting and adjusting and using your own version of it, then your B2 is not my B2. Don't mess with it. Leave it as it is, as a standard, as a framework. And if we all communicate in the same way, we can then start lowering the threshold of confusion. I think that will be my last comments. Yay! Questions? Don't be shy.
Any questions? So there's one.
Oh, he's running to the microphone. Like it.
Can you hear me? You can. Well, I was sitting far away, so it took my breath a little. I have a question about the information credibility because it's relied very much on the number of sources confirming it. Is it ideal situation because, you know, threat actors can boost that one by posting the same thing on various places, various forums, and does it make it, you know, less useful?
Okay, there's a lot of echoes. I'm not sure I heard you correctly, but I think you said that some users are publishing on multiple forums and then it's creating more noise sometimes.
Yes, and it's boosting the score, right?
Boosting the score, yes, now I got it. Okay, so one of the examples I used, right, is the last point okay, they turned it off so I can't go back, but one of the examples I had was that you have multiple users sometimes talking about the same thing, and at the end we see, hey, there's similarities in usernames, same IP address, we're seeing connection between different users on different forums, actually then consolidating for me that they're talking about the same case, and the suspicion that we're trying to look into then, is it the same person or persona? We thought it was, but that was our assessment at the time. So yes, it can confuse, but then when you look at the metadata and trying to figure out who is, I mean, not who it is, but are there connection between these different handles and usernames and personas? That's part of the job that we're trying to do. Yes, it creates confusion, but that's when you got, in Norwegian we say, you have to have the tongue in the right place, otherwise you're going to bite it type of thing. So you have to really be certain and work through this and navigate this correctly. Yes.
Okay, thank you.
You're welcome.
Any other questions?
I will be around. Oh, there we go.
One last one.
Oh, there we go.
Thank you for your talk, Freddie. Very good. In terms of time management, sometimes you have a lot of pressure on delivering a product.
Mm-hmm.
How do you then do your app entry the right way and do your bias confirmation?
Yeah. So here's the thing, right? When the building's on fire, should you do all the SATs and should you spend like 5 hours on this? No, that's the easy answer. One of the comments I made before, right, the caveat, right? If the building's on fire, sometimes you have to cut corners, but talking to your colleague for 5 minutes will cost you nothing in terms of the big picture. That person will challenge you a little bit if you have your assumptions, if you have you're going down the wrong path or deep down into a rabbit hole. Having that conversation is a good thing. And then saying just, hey, I think this is a B2 and here's why. And then your colleague will say, I don't agree because I think it's a C5 because, and then that person will make that argument clear. And then either you listen to the person and then make corrections, or you're just going to, okay, let's take it out this time because it's confusing more than it's supporting. Should you use it for strategic reports? I don't think so. For tactical, technical, yes, I think so. Because it helps us to try and trust the information that we generate. Yes. I think I need to leave the floor for someone else to take over.
If there are one urgent question, I think we have the time, but doesn't think so. Thank you very much.
Thank you. Have a good day.
So the next talk will be by Adam. He will talk about ransomware profiles. Really looking forward to it. This one will be TLP green, so you know the rules. Please follow the rules for this talk. And Adam, the stage is yours.
Thank you. Thank you.
come to the last talk. Xavier, you will talk about what's behind the acronym HA, and I'm very curious about
exactly, that. Exactly. Just let me verify that it works. Like this. Okay, perfect. Thank you all for waiting my talk and still be available in this big room. I know that it has been a very 3 intensive days. You attended a lot of interesting talks, and I hope that mine will be also interesting, which is maybe, I think based on what I saw, it will be the most technical ones. But don't be afraid. I'm promised no assembly, nothing like this. So the topic is HA, high availability, or not high availability, but hunting automation. The idea of this talk is, it came with this. I like reverse engineering. I like to play with malware, to do some hunting and so on. And basically, in the malware landscape, malware analysis landscape, you have 2 types of reverse engineers. The lucky ones and the unlucky ones. What does it mean? The lucky ones is less than 1%. That's all these people working for big company, big names, like just mentioning a few of them. Unit 42 from Palo Alto, Checkpoint Research, Cisco, Talos, and so on, big players, big names. What they do, they hunt, they get a sample, they analyze the sample from A to almost Z, they produce a paper, and they make some noise. So they talk and they promote the brand for the company they are working for. The remaining part of reverse engineers, the unlucky ones, like me, and probably like most of you in this room, we don't have time. And we do malware analysis in the context of an incident. I'm working on an incident, I found a piece of malware, and my customers, hey, Xavier, can you have a look at this? Can you analyze it? You say, oh, of course, I like this. Please, 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 give me some time. You have 2 hours. Oh, my God. So that's the unlucky ones. So that's the idea of this talk. A few words about myself. I will do very briefly because we don't have a lot of time, and I know that I'm the last speaker. So my name is Xavier. I'm a Belgian guy. My day job is freelance consultant, so cybersecurity, of course. And besides this, I'm also instructor for SANS. I'm teaching, guess what, malware analysis, the 4.6.10 and the advanced, the 4.7.10 trainings. I'm also part of the Internet Storm Center. I hope that you know the Internet Storm Center with the famous stormcast produced by Johannes every day. 5 minutes podcast. In 5 minutes every morning, you get an overview about what happened in the security landscape for the previous 24 hours. Super cool. And of course, I like to hunt malware, to hunt bad guys, and I'm also the co-organizer of the Brucon Security Conference in Belgium. The idea is like this. So you see on the left, on the right side of the slides, some diaries that I publish on the Internet Storm Center. And the question that I usually have from the readers or from people who contact me and say, hey, Xavier, how can you find this? Because you produce some content, you analyze some malicious script, Python, PowerShell, binaries, and so on. But where do you find them? How can you find fresh meat? It's one of the classic issues when you start to learn reverse engineering. You have the motivation, you have all the tools, but where can I find samples, interesting samples? And that's what I will explain you today. From the reverse engineering point of view, this is the wonderful pyramid of pain that probably a lot of you can apply this pyramid to any topic. Basically, we start with automatic analysis. Then you have the static analysis, behavior analysis, and code analysis. More you go to the top of the pyramid, more it's becoming interesting / challenging. Normally, when you start to learn reverse engineering, you don't pay attention to automated analysis because it's just easy. You take a sample, you drop it in the sandbox, and boom, some magic will happen from time to time. That's what we will do now. So today I will only cover automated analysis because we have to speed up the analysis. We have to go straight forward, straight to the point. What are the interesting samples? Of course, many people, they think that reverse engineering is super nice because you play with disassemblers, debuggers, it's super nice, super cool. When you show this to your friends, oh my God, it's like a matrix screen. You have a lot of codes and so on. Oh. But the problem is that it's time-consuming. As I said in my introduction, the lucky reverse engineers, the unlucky ones, we don't have time. So, also pay attention that I'm not doing reverse engineering as a full-time job. I wish I could do that, but it's not my day-to-day job. Reverse engineering, some people, they think that is this. Of course, I said no assembly, but I had to put some assembly on one slide at least. Also, you have a lot of obfuscation techniques. It's probably my favorite topic. I like to detect new anti-debugging techniques, obfuscation technique, and it's really crazy how people have crazy ideas. Attackers, they have plenty of ways to obfuscate the code, to find super cool technique, and really, I need this. So, where can we find these sources? Let's go right to the point. First, sources are real cases, some customers. Of course, I always respect the TLP and my customers. If I had to work on some TLP red incident, I will, of course, never use them. But when it's a sample which is not so malicious and the customers say, yeah, no worries, I can work and I can disclose, write a diary about it, and so on. Of course, I will never mention any names and so on, but sometimes a customer comes back to me and says, hey, I saw your diary last week. It's about all cases. Yes, because it saw some interesting strings and stuff like this. So very interesting, but you have to respect the TLP and so on. Another source is all of you. As I said, I'm part of the Internet Sum Center, and if you go to the website, you see that you have a contact page, and you can submit us any type of file. If there is a website on the internet where you can submit almost anything except VT, that's this one. We accept anything. So you just fill the form and you submit your files. We like this because we have fresh meat, and please, if you find interesting samples, share them with me. Please, 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 please do that. So that's manual submissions, and the readers, the people following the Internet Sum Centers, they provide some fresh meat. Another super interesting source of information, my spam. I like spam. I don't delete any emails. I have some domain names that I registered them maybe 20 years ago. So trust me, they are part of any spammer list over the world. And I get a ton of samples every day because I'm part of every malicious list. So I have a lot of mails like this. So what does it mean? For these old domains, when I receive the renewal information from the DNS services, I say, oh, do I pay or not? Okay, I pay for an extra year because I know that I will get interesting samples. So on this, I don't read them, I don't manage this domain, but I just have a catch-all mailbox. So I accept everything, everything. And all the documents that are sent to these mailboxes are extracted and fed into a system that I will describe in a few minutes. So basically, that's the first step of extraction. I process automatically all the attachments. Here we go. Another source, of course, the wonderful VirusTotal, VT. I'm lucky to get access to a VT Pro account through the Internet Sum Center, so I can do some hunting, I can create Yahoo rules, I can do some retro search, I can download samples and so on. That's what I do. I have a bunch of Yahoo rules, and I hunt for interesting stuff. I change them almost every week, depending on the new trends and so on. I'm searching new strings. For example, this one is regarding PowerShell stuff. And then I have a script, and every time I get a hit, I download the sample and throw the sample into my pipe. To do this, I have a bunch of tools like vthunting.py, so a Python script that will just fetch the VT API. So every time I have a hit using a Yahoo rule, it gets notified by VT. I check VT every hour. I download the files, and so on and so on. So why we need automation? Because you see that I have a bunch of sources, so it means a lot of samples. And the two main issues are a lot of samples, and not all samples are interesting. 99% of them are not interesting. So the fact is, when you see, this is a graphic that I generated a long time ago. It's coming from Malware Bazaar, and you see that we have a huge amount of, it's like a huge amount of samples every day. I don't know if it's the case for you, but I'm a lazy guy. If I can automate, I will automate. Don't ask me to do manual stuff all the time and so on. So I had to automate, and that's what I will present you. First, a disclaimer. All the tools here are based on open source solutions, and probably, I'm pretty sure that there are other solutions. You know that when you use open source, for example, for your mail server, you may decide to use postfix, I know postfix, sendmail, and so. The goal here is not to start a flame war. This is my solution. That's the choice that I made. I will present them to you. Maybe you have another type of solution, or the tools and so on. We can always discuss. I'm always open to discussions, but please, no flame war. That's not the goal of this presentation. Another disclaimer, a lot of companies today, they like to start with automation and no-code solutions. What does it mean? You have a nice screen and you connect bullets, rectangles, and so on, and you just create funny automations. I'm not a big fan of this. I have some customers who decided to go this way, and the problem is that at a certain point, they have to fall back to code because you can't fully automate everything. So they have a nice tool. I will not mention any commercial names, but sometimes they have to fall back to a bunch of Python script because the feature is not available or they need to expand the tool. So once again, in this case, so all these tools, it's security, orchestration, automation, and response. That's what we will do, orchestration, automation, without the R, no response. Let's go for this tool. The first one that I use is called Carton. Carton is, I'm a lazy guy, as I said, so it's just a definition coming from the website. This orchestrator has been developed by the CertPL in Poland, and it's also based on open source components. You have a few of them, Python, Redis, Minio for the storage, and so on and so on. Why I've selected this one? Because first, it works. I know the guy behind the tool, and it's easy to expand, because I like to expand and to fine-tune the tools to fully cover all my specific needs. That's what I have. You have some samples coming from VT, my catch-all mailboxes, and so on. It's sent to Carton via REST API, for example, and then you have a classifier, and the classifier, depending on the file type, it will execute some modules. If it's a Word document, it will try to extract a VBA macro. If it's a .NET program, it will decompile the .NET, and so on and so on. And the good point is that you have a nice dashboard when you can follow the activity of this framework and so on. The orchestrator has different plugins. So call them plugins / modules / whatever you want, and you have a lot of them here. For example, you have extracting from ASCII strings, it executes against Cape, lookup VT, lookup against malware bazaar, triage, a Cape instance, OLA VBA, Yara matcher, auto IT extractor, config extractor, ELSPI CMD, Gijra decompile, blah, blah, blah. Some of these modules are present by default, so they're provided in the framework. Some of them, I developed them by myself. For example, the Gijra decompile, I made it myself. So basically, once I have an executable, I run a Gijra headless, decompile everything, and I store the source code directly in the framework. So I have the source code, the pseudocode of the malware. Some services, so archive extractor, if you throw a zip file, an ISO file, an RAR file, whatever you want, it will be automatically extracted. They will extract configuration for well-known malware. Why spend your time to extract some configuration from an Xworm, an Agent Tesla, if you can automate? MWDB reporter, we will talk about MWDB in a few seconds. You can, of course, run a bunch of Yara rules, you can extract strings, you can process auto IT scripts, and so on and so on. The second tool is, because you need a repository, is called MWDB, Malware Database. Once again, it's a tool developed by CertPL, exactly the same. And you have a super nice parameter, which is this one. If you enable carton equals 1 in the MWDB ini file, poof, the two tools are automatically integrated. And it's super nice, because that's what you have. It's something like VT, but it's my own instance. The good news, of course, is I can throw to this pipe any type of file, because I maintain everything. It's running on my server and my infrastructure, so I don't have the risk to share sensitive files if you upload them to VT or any other tool. And you see that you have classic information, all the file, the hashes here to the SSD, upload time. In this case, we see that you have an agent Tesla. Automatically, it's extracted, the credential, host, email, password, protocol, blah, 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 everything. And of course, you can share it if you want with some groups. For example, we have a group SANS Internet SOM Center, so I can share automatically samples with my colleague from the IC and so on. That's MWDB. How you can expand Carton, that's the goal. It's super easy to expand. Because it's written in Python, if you have some Python skills, you just expand as you want. You have a Python library, you have a Python library, which is available, so super easy integration, and everything is based on a class. This is an example of Python script. So you define your class. I will not explain this. I'll just briefly define the class. You have a tool. Depending on the filters, the type of file that you provide, you have a process. You call, for example, a specific tool. You save the output, and then you submit the output directly back to MWDB, and you can expand the capabilities of the malware like this. And you have, like you saw on the previous slide, like this, you have here all the child relationships. So you can have, for example, here, I have, what is this? Carton strings, carton.net file, and so on. So you can expand, and you can browse the capabilities of the malware. So easy to expand. I really like this. Some example of plugins that I wrote: Carton Cape to submit to a Cape sandbox, PDF ID to automatically submit, to analyze PDF files, Carton Kappa. So Kappa is also an emulator to emulate API calls of a P file, OLA VBA to process VBA macros from Word document. Of course, I have some enrichment modules, so I check on Malware Bazaar if the sample is present. If it's present, I will just extract the tags and I will retag my sample in my own system so I can enrich everything. Die classifier, so detect it easy, ELSpy, CMD, and so on. So basically, if you know a bit of reverse engineering and malware analysis, you recognize these wonderful names. There is nothing super special. Regarding new threats, because we can easily add more modules, but this one is not a very brand new one because the MSI-X format is not super new, but when I detect there is a new type of file and so on, you can just easily write your Python module, and the new MSI-X format from Microsoft, so which is a Microsoft package, you see that Microsoft had the wonderful idea to add a config.json, and if you go in this file, Microsoft added script path, and you can automatically execute a file once the package has been installed. Guess what you will have in this wonderful PowerShell? A nice gift, of course. It will be a backdoor, it will be something, I don't know. So basically, you can write a plugin to automatically extract this kind of script and enrich the system. Of course, how can you feed this? You can feed it using a REST API. So once again, full automation. So it's super easy to integrate it with third-party tools. And for example, a tool that I use every day, I wrote mwdb.py, and I can automatically, for example, fetch a file from VT, from Malware Bazaar, from Virus Share, and so on, and feed my system so I can automate as much as possible. Once again, automation is key. If you like to submit another tool that I use from my catch-all mailboxes, submit to mwdb.py, and you just feed the system like this. Of course, I had to add some filters because I'm not interested in pictures, in ICS files. One day I was flooded by DOS MBR boot sector files. I had to block them because otherwise my system was dead. So basically, the complete infrastructure now, you have samples. The samples are sent to MWDB. MWDB, by the way, I did not mention this, but it's used an S3 compatible storage, which is based on Minio. MWMini calls Carton. Carton calls different services. And of course, because I have to mention this, Carton is compatible with MISP, so you can create events and you can feed your MISP instance with interesting IOCs. Regarding the sample, I repeat, my catch-all mailboxes, VT, the Internet SOM Center, Malware Bazaar, and others. If I had to add some of them, it's pretty easy, piece of cake. Conclusion, I have a lot of sources, and you need to have multiple sources. Automation is key, once again, because I don't ask me to spend hours to do some triage and process my samples. It's easy to expand, so if you get a new type of file, just write a piece of Python. The issue that I have right now, because this system is used only by myself, I never paid attention to the scalability. What does it mean? It works for me. I have enough storage, I have enough CPU, enough memory, but I don't know what will, yes, I know what will happen if I feed my system with 5,000 samples in one row, it will crash, basically. But that's my own system, so I'm not really affected by the scalability. What's next? I don't know. If you have crazy ideas, let me know. One idea, I have a to-do list of new plugins that I should develop, but I have no time. Of course, one of them is to automate the disassembly using AI, of course. You can already integrate Ghidra with ChatGPT to ask ChatGPT, hey, this is a function, tell me what the function will do. What's the purpose of this function? It works pretty well. Maybe I will do this in the future. And of course, the idea of this system is to perform some hunting and to get rid of the non-interesting samples. If I throw 500 samples in my system, maybe only one of them will be interesting because it's not detected. And in this case, what do? Back to the roots and manual analysis, and I do my job as usual. So it was a quick introduction. And I think that I'm on time, and I have maybe some time for questions. So if you have questions, let me know.
Any questions?
I don't want to borrow your time because maybe some of you have to catch planes, trains, bikes, trottinette, and so on. So
I think it was a lot of information. So
any questions?
Last chance.
Okay. The slides are not available anymore, but you can try to reach me via Twitter, LinkedIn, Mastodon, and so on. My email address is almost everywhere, so feel free to contact me if you have some crazy ideas, if you need more information. There is a question over there, I think.
Oh, okay.
Yes. Thank you.
So thank you for the presentation. I found it quite interesting. And my question is, if we want to support you, I mean, maybe you have some ideas, you don't have time, but for example, I feel like this is doable with my skills. How can I join you? How can I know really what you want to do? And how can I maybe help you in the development of the plugins?
So, first, thank you for your interest. This system is closed. So what does it mean? Well, when I say it's closed, I use it for my own research, my own job, and so on. As I said, it's open to some friends, it's open to the other members of the Internet Some Center, and so on. And my goal is not to open it to everybody, definitively not. Because, as I said, I have a scaling issue, I'm pretty sure. The different scripts that I wrote, if you're interested, I can share them with you. But I like to say that I write shitty code. What does it mean? It works for me. It does not mean that it will work for you. You see what I mean? So it's based on Python. I don't have a GitHub repository. I don't have time to do that. I know that I should publish them and clean up the code and make the code more clean. For example, avoid API keys inside the code and stuff like this. You see the problem? But I'm not a developer. I write shitty code. It works. But I'm ready to share some piece of code. So if you would like to, for example, the one that I mentioned, the Ghidra decompiler using the Ghidra in headless mode, I can share it with you. There is no problem. But it's not open code right now because I have to perform a big cleanup before. Yeah.
Okay.
Not
then
a question? No. Where?
You should have told me that before. Good.
No, not you.
Thank you for the presentation. I have one question. Once you automate the processing, how do you go to the detection rules? Do we have an automated process for that?
No. No, because as I said, if you remember in my slide, I mentioned SOAR without the R. I don't have the response component, because this tool is not used in the context of a company organization that I have to protect. It's for my own research. So I don't have these capabilities. The only thing I do is I just push some events into my MISP. Yeah. But of course, you could, for example, create a module to create some Sigma rules or stuff like this. Of course, it's just a question of code. But in my personal case, I don't need the R, the response component. No more questions?
Okay, final chance.
3, 2, oh, over there? No? Okay, thank you very much again.
Thank you very much.
Bye-bye. This was for you.
Oh, I don't. Thank you, but I don't have slides. Yeah, with that, I can close this 2025 edition of the CTI conference. For me, it was a huge pleasure to be here. I hope you also enjoyed it. You should have received an email where we ask for a survey, your feedback. So the feedback is really important for us that we improve it. And then, I don't know, do we have the slide with next year? So next year we'll change location. We have the same dates, 21st and 23rd of April. However, we will go to Munich, where it all started 10 years ago. And I hope we see us all again next year in Munich. And with that, safe travels home and see you next year. Bye.